Hi there, this is Ryan. In this video, I'm going to be chatting about nuclear weapons, what they are, how they work, how they change or haven't changed global politics, and what they mean, not just in debate, but also in international relations. Before I get started, though, there's a couple of important disclaimers to get out of the way. The first is that this is a presentation that by its nature is rather disturbing. And there is good reason for it to be disturbing. Nuclear weapons are, by almost all accounts, tools of genocide, and it's pretty difficult to discuss nuclear weapons without acknowledging the definitionally grim nature of what they are. There will be specific segments of this presentation that are more graphic than others. In particular, the discussion both of the bombings of Hiroshima and Nagasaki will be more jarring, as will discussions of World War II in the context in which the Manhattan Project occurred. If that is triggering to you, of course, don't listen/watch those sections. It will not meaningfully detract from the quality of this presentation, hopefully. That being said, there is a lot of value, at least in my opinion, in having some exposure to the brutality of nuclear weapons, what they do to people, how they work, and the context in which they were deployed. Nuclear weapons are best understood as they actually exist, and I think to some extent that does require discussing and dealing with some rather traumatic material. The second disclaimer is I'm not an expert on nuclear weapons by any accounts. There are people far smarter than I who write about, talk about, discuss, chat about nuclear weapons all the time. You should definitely listen to actual smart people on this subject, much more than me. And you should probably consult external resources to verify the things I say. Obviously, this presentation is based on the research compiled by other experts, but that doesn't mean that I can't make mistakes or be wrong, especially on more complicated elements of the nuclear weapons debate. Lastly, the crude reality is that most of this presentation doesn't matter to your debate career or to debate in general. And even in cases where nuclear weapons are debated, it's probably unlikely that this presentation will meaningfully help you. So the goal of this presentation is less about improving your win rate in nuclear weapons debates, and more about establishing a good fundamental understanding of what nuclear weapons are and what they do to countries, both with and without them. And so if you're here primarily for debate reasons, you probably will be disappointed. If you're here to learn something about nuclear weapons and maybe apply that to debate, that will probably be a bit more useful. That being said, to the extent that you do care foremost about debate applications of nuclear weapons advice, the first part of this presentation will probably be relatively unhelpful. That part will discuss the sort of physics behind nuclear weapons and is probably the least relevant from the perspective of a debater. Those are the disclaimers out of the way, but there's one final comment I'll make very macroscopically before jumping into substance. And that is almost all of the questions or issues that I'll raise in this presentation have no objectively correct answer. And on almost all matters of nuclear policy, there are legitimate diverging opinions that have some level of defense. So, for example, if you ask a question like, was the invention of nuclear weapons in 1945 regrettable for humanity? There are extraordinarily diverging answers to that question. There's one school of thought that says nuclear weapons have saved tens of millions of lives and prevented great power conflict in a way no other invention ever has. There is a different perspective that says nuclear weapons are the greatest instrument of death ever concocted, and the mere existence of nuclear arsenals threatens humanity at all moments in time. Both of these perspectives have legitimacy, and there probably isn't a correct answer to this question. Same issue for a question like, was it justified for the United States to bomb Hiroshima and Nagasaki in August of 1945? The candid answer is no one really knows, because what we know for sure is that the bombings of Hiroshima and Nagasaki were mass campaigns of death against innocent civilians. We also know that in the absence of bombing Hiroshima and Nagasaki, there was not a guarantee of surrender, and it's unclear the degree to which a continuation of the war may have resulted in even more innocent civilians dying. Again, there's no right or wrong answer. Same thing for a question like whether or not nuclear weapons are ethical. The point is, these questions are thorny, they don't have clear answers, and this presentation will hopefully provide you with background information to contextualize these questions, but I'm not aiming to give definitive answers to questions like, do nuclear weapons on net benefit the world? Was it justified to use nuclear weapons against the Japanese forces, and so on and so forth? So this presentation will be structured around 7 broad questions. The first section will look at just very physically and technically how nuclear weapons work. The second will examine the context into which the nuclear age was born. The third will discuss nuclear deterrence, whether deterrence works and where deterrence might fail. The fourth section will look at nuclear proliferation and exactly how much we should be terrified of nuclear proliferation. The fifth section will talk about how you defensively protect against nuclear attacks and whether or not ballistic missile defense is viable. The sixth will talk about the changing era of counterforce and how technological advancements are undermining security. The last will discuss ethics. Admittedly, the seventh question is the question that I have the fewest insightful thoughts on, for the reason that I'm particularly not great at philosophy, and you probably should listen to actual philosophers much more so than myself on that question. I'll just offer thoughts that potentially may be interesting. First question, how do nuclear weapons actually work? And it's easy to disregard this as kind of unimportant, but I think there are 3 reasons you should care about the science behind nuclear weapons. The first is oftentimes debates around counterproliferation or disarming the world of its nuclear weapons. Those debates are much easier to understand if you have a reasonably good idea of what nuclear weapons actually are, as opposed to a sort of mystical view of nuclear weapons as these magical forces of destruction. The second is lots of arguments made about nuclear weapons are somewhat or sometimes based in sort of just fear-mongery rhetoric that nuclear weapons are destructive and dangerous. And it's usually more persuasive to ground those arguments in an actual explanation of what nuclear weapons can, and more importantly, cannot do. The last is, every time you debate nuclear weapons, implicitly a distinction is drawn between conventional, which is to say non-nuclear weapons, and nuclear weapons. And distinguishing nuclear weapons from non-nuclear weapons is difficult because most people's intuition is that nuclear weapons are just really big bombs. Like, you just take the largest existing weapon in a military arsenal and multiply it by some factor and you get a nuclear weapon. Understanding the actual science behind nuclear weapons makes it clearer what nuclear weapons are and how they compare directly against conventional munitions. So at the core of the physical explanation behind nuclear weapons is explosions. Nuclear bombs, at the end of the day, just create an explosion. What is an explosion? The short answer is an explosive device releases energy. Energy is absorbed by nearby air molecules. When nearby air molecules absorb energy, they become superheated, they expand rapidly outward, and you get a shock wave. Now, obviously, the more energy that is released, the more energy that is absorbed by the air, and the more energy that is absorbed by the air, the more powerful that shockwave will be, and hence the more destructive that shockwave will be. Explosives typically release energy either through chemical reactions or physical detonations. And they, of course, can also have lethal effects in other ways. So, for example, some physical explosives will also combine things like shrapnel, such that you don't just get a shockwave, but you also get alternative ways of affecting harm onto nearby individuals. So, for example, the Boston Marathon bombings carried out in 2013, those featured what are called IEDs, or improvised explosive devices, that were based out of 2 pressure cookers. What the terrorists in question essentially did was pack pressure cookers full of bearing balls, explosive gunpowder, and shrapnel, primarily nails, such that when the pressure inside those pressure cookers increased significantly, the pressure was too much, the pressure cooker exploded, creating a very small shockwave, but more importantly, releasing huge amounts of shrapnel that killed, I think it was 3 people and injured well over 200. If you look at a different example of an explosive, the Qassam rockets used predominantly by the Hamas militant group, these feature chemical explosions that create and release energy as well as create fire, which allows these rockets to have destructive potential. The question that's worth asking is, most explosives create detonations through chemical or physical processes. How destructive are those processes, and how do nuclear weapons compare? So if you want to measure an explosion, you usually do so by comparing a weapons explosion to how much firepower is released when you blow up 1 ton of TNT. TNT is just a highly explosive chemical. When it's detonated, it blows up, somewhat famous for that cause. And so we usually measure explosiveness or destructiveness in terms of tons, where 1 ton refers to the destructiveness of blowing up 1 ton of TNT. So how destructive are regular explosives? And the short answer is, if you take your regular average civilian firework, it's practically nothing. Same thing for a grenade, same thing for a rocket-propelled grenade. Now, if you start talking about more serious explosives, so for example, the Tomahawk cruise missile is one of the probably most powerful missiles in the US military arsenal, you're looking at probably around a half a ton worth of explosive force. The Oklahoma City bombing of the 1990s, that involved about 2 tons worth of force. If you go up a little bit, the largest explosion ever created in a single blast by a single weapon came in April of 2017. The MOAB, or Massive Ordnance Airburst, also commonly called the mother of all bombs, MOAB, was dropped on ISIS-KP militants in Afghanistan by the Trump administration. The MOAB released 11 tons worth of force, and that remains to this day the most singularly destructive blast from a non-nuclear weapon. The key question to then ask is, if this is the explosiveness and the destructiveness of conventional weapons, how do nuclear weapons compare? The short answer is it's staggering. The explosions at Hiroshima and Nagasaki are multiple orders of magnitude more powerful than the most powerful explosion ever created without nuclear physics. So the dropping of Little Boy, which was the bomb dropped on Hiroshima, generated 16 kilotons worth of force. That's equivalent to detonating 16,000 tons of TNT. Fat Man dropped on Nagasaki came in at over 22,000 tons. Just by the way, these nuclear weapons pale in comparison to modern nuclear explosives. The most powerful explosive ever detonated in human history was called Tsar Bomba by the Soviet Union in the early 60s. That released over 50 million tons worth of explosive potential. That type of potential is literally more destructive than most volcanoes will release. It's truly staggering. So when people say things like nuclear weapons are just big bombs, it really misses the point. Nuclear weapons are not just large explosives. They are a different category of explosives. They are destructive in a way conventional explosives literally could never be. This is not just a powerful bomb, it's a new type of weapon. And this is literally what it looks like to blow up 16,000 tons of TNT equivalent explosives. This is what you get. You get entire cities razed to the ground, blown literally to non-existence. And that is what happens when you use a nuclear as opposed to conventional explosive. The central question to ask is how. These weapons are explosive and destructive in a way few others are. How do we explain that? And 2 central physical principles lie at the heart of the answer: fission and fusion. Fission traces its origins back to the late 1930s. At this moment in time, scientists discovered it was possible to split the nucleus of an atom. This discovery was immediately understood by the scientific community as revolutionary. This is the subject of Einstein's now very famous letter to President Roosevelt, warning of the ability to create an extremely powerful bomb, harnessing the power of a nuclear chain reaction. So in order to understand a nuclear chain reaction, it's useful just to do a brief review of chemistry, or at the very basic level, have an understanding of what an atom contains. An atom contains broadly 3 things. It has protons, which are positively charged, and neutrons, which are neutrally charged, both located in the very densely packed nucleus of an atom. Surrounding that atom, there is a massive field in which electrons, which are negatively charged, move around. But the central part of an atom is its nucleus, in which protons and neutrons rest. The principle of nuclear fusion is when you bombard that nucleus with neutrons, which are neutrally charged, the nucleus sometimes splits in two. And when the nucleus splits in two, three products emerge. First, you get new elements. In other words, instead of having the original atom, you have new atoms composed of different numbers of protons than the original atom. Secondly, you get neutrons. When you split an atom, not only does it form new atoms, it also releases neutrons, which are called liberated from the atomic nucleus. And third, and most importantly, splitting the nucleus yields energy. And the reason why splitting the nucleus yields energy is that when you split the nucleus, you get, as an outcome, mass that is lost and converted to energy. And Einstein's very famous equation notes that when you have energy or when you have mass, they can transfer into one and the other. And the mass that is lost when the nucleus is split, that mass becomes energy and hence is released in an exothermic process. The most important fission reaction out there is a fission reaction that goes something like this. If you take an isotope of uranium called U-235, 235 indicating the total number of protons and neutrons, and you bombard a U-235 atom with a neutron, that will split and will ultimately form two new atoms, barium and krypton. It will, on average, produce around 2 neutrons and release around 200 megavolts worth of energy. Now, the key question is, why could this sustain a chain reaction, as the common saying goes? And the short answer is because nuclear fission is caused by a neutron hitting an atom, and nuclear fission releases a neutron, you can create a chain reaction whereby the neutron released in one reaction drives nuclear fission in another reaction. And this is how you can end up getting a chain of nuclear fission reactions where neutrons are liberated from their original atoms, and those neutrons then go on to affect and to induce, basically, fission in other uranium atoms. But there's an interesting catch here. Chain reactions involving nuclear fission seem ideal for explosions. Why? Because as we mentioned before, nuclear explosions, or explosions of any kind, destroy things by releasing energy and creating a shockwave. So in order to get an explosion of huge potential, you need to release a huge amount of energy. Nuclear fission shows the potential to release a huge amount of energy by creating a self-sustaining process of a nuclear chain reaction. But not all atoms can sustain a nuclear chain reaction. And as a matter of fact, there are just 2 isotopes in existence, U-235 and Pu-239, that are capable of sustaining chain nuclear reactions. This qualifies U-235 and Pu-239 as fissile materials. Notably, lots of atoms are fissionable, which is to say you can split the atom, but they are incapable of being fissile materials, which is to say sustaining a chain reaction of nuclear fission. Why just Pu and uranium? The short answer is these are very unique isotopes in that they're able to experience or undergo fission after absorbing either fast or slow neutrons, as opposed to just fast neutrons, which is true of most other atoms. They also have pretty long half-lives, so there's no risk of them unintentionally or accidentally undergoing nuclear fission while they're just waiting around prior to detonation. And because they have large nuclei, they're able to overcome what's called the alpha N reaction problem, which essentially is when impurities in fissile material release unintentionally neutrons that have the potential to induce fission prematurely. And perhaps most importantly, these 2 isotopes are very rare in that they have extraordinarily powerful nuclear cross-sections, which means every neutron that strikes one of these 2 isotopes has a relatively high probability of inducing fission within that atom. But there's a bit of a problem here, which is although uranium and plutonium are excellent candidates for nuclear fission, they're not great candidates for weapons programs. The reason is plutonium does not exist naturally, and the vast majority of uranium in natural existence is not the type that we want. It's actually a different isotope of uranium called U-238. And the reason that matters is to build a nuclear weapon, you must assemble a substantial quantity of fissile material. That is not easy, and we'll talk more about this later when we chat about supply-side counterproliferation. But for a moment, let's skip over that part and assume, for sake of thought experiment, that you have assembled, as a country, a substantial quantity of fissile material, either uranium-235 or plutonium-239. In order to actually build a bomb, you need to design a weapon that is able to harness the power of nuclear fission. And there are two broad designs that countries probably, and I say probably because obviously a lot of this information is classified or probably classified, there are basically two broad designs that countries probably use to ensure the fissile materials they've assembled undergo the correct chain reaction when the bomb needs to detonate. The first way you could do this is what's called a gun-type bomb. Essentially, what you do is you separate out your fissile material between two ends of an artillery gun. You fire one of those uranium or fissile masses towards the other. Once those two masses hit, they become what's called critical density, which is the density at which chain reactions of nuclear fission can be sustained. And subsequently, you throw a neutron into the mix. Once you've thrown a neutron into the mix, you get fission and you get a detonation that releases energy. You alternatively could secondarily use what's called an implosion-type bomb. This is where you pack all of your fissile material at subcritical density into a pit. You surround that pit with regular chemical explosives. You then blow up those explosives all at the same time. That puts a ton of pressure on that fissile pit, and you massively increase the density of that fissile material, hence inducing fission. This is what these two look like. The first shows a gun-type method. The second shows an implosion-type method. In either instance, you get similar outcomes, which is to say nuclear fission. Nuclear fission releases a tremendous amount of energy because each splitting of the atom yields both energy and also neutrons, which then induce fissioning in other atoms. This, for example, is the design of the weapon dropped on Hiroshima. This is the design of the weapon dropped on Nagasaki. A quick side note. No one quite knows how countries generate neutrons in the context of nuclear weapons specifically. It's really anybody's guess. This information is by and large heavily classified. There are some declassified reports that gesture broadly to how countries generate neutrons within nuclear weapons, but in terms of the specific details, I don't know, kind of wacky. But of course, if you're familiar with nuclear weapons, you probably know that fission is only one half of the equation, because there are other weapons that weaponize a different type of reaction called fusion reactions. Now, for some odd reason, terminology around the fusion bomb gets weird. So just a quick clarifying note. Atomic bombs usually refer to fission bombs, and hydrogen bombs usually refer to fusion bombs, as do thermonuclear bombs. This is weird, though, because there has never in all of history ever been a weapon that purely uses fusion. Every fusion weapon ever developed, including to this day, combines fission and fusion in a two-step process. And in particular, what fusion essentially does is it generates energy through the inverse process of fission. Fission splits large atoms like U-235 or Pu-239 into small atoms and releases energy in the process. Fusion does the opposite. Fusion releases energy by taking small atoms, usually isotopes of hydrogen, and combining them into one larger atom. Now, typically, most fusion bombs utilize two very specific types of hydrogen isotopes. They're called tritium and deuterium, which are essentially just different isotopal variations of hydrogen. When you fuse these two together, you get a neutron, and you also get a staggering amount of energy. Now, there's a bit of a problem here, which is that it's really difficult to fuse different isotopes together for the very simple reason that you only can fuse two atoms and two nuclei together under enormous amounts of pressure and heat. Most estimates say that you probably need to heat up two atoms to the heat of the temperature of the sun to induce fusion. And on top of that, getting that particular hydrogen isotope, tritium, is not easy because it's radioactive by nature, so it's difficult to store. Fortunately, the first problem is solved through what are called lithium blankets. What most fusion weapons have is a blanket of lithium, which then is pounded with high energy neutrons. As an outcome of that, you get tritium, which is then used to power fusion as fusion fuel. And interestingly enough, the solution to that second problem of you need tons of pressure and heat to induce fusion, curiously enough, this is solved through fission. And here's how. Almost every thermonuclear bomb that's been developed probably, and again, I say probably because the definitive answer probably isn't known, combines fission and fusion to get a really destructive bomb. And the way it works goes something like this. You start with a fission bomb at the very top of your weapon. You detonate your fission weapon. That fission weapon undergoes, shocker, fission. And what happens as your fission weapon undergoes fission is that you release an enormous amount of energy, and you release heat, and you release a whole bunch of radiation, including X-rays and a whole bunch of other heat. Why does that matter? When the fission weapon releases heat, it immediately radiates and vaporizes the rest of the gunk inside your fusion bomb. Usually it's polystyrene foam. And that foam is rapidly superheated into plasma. Why does that matter? Because that plasma immediately puts tons of pressure on the other thing inside your fusion bomb, which is the fusion pit, which is where your fusion fuel is located. So what you get then is tons of pressure and tons of heat on your fusion pit, which begins to compress and to induce fusion within the fusion fuel. At the same time, by the way, there's another fission device prepared in the weapon. It's not a fission bomb per se, but it's certainly a fission device. There's a plutonium spark plug on the underbelly of the weapon. And as the initial fission weapon goes off, it releases neutrons. Those neutrons strike the plutonium spark plug and induce fission in the plutonium spark plug. As the plutonium spark plug starts to fission, it also starts to apply heat and pressure, but this time to the inside of the fusion weapon. And so what you end up getting, in essence, is pressure and heat on the fusion fuel, both from the outside plasma and inside fissioning. When you get those two things happening at the same time, you get a tremendous amount of pressure on your fusion fuel, and you get, as a consequence, fusion and enormous amounts of destructiveness. So that's the science behind nuclear weapons. And it matters for a couple of reasons. One, it matters because nuclear weapons are not magical. Splitting the atom is not a mystical or mythical process. It is a scientific process that is understandable and makes perfect scientific sense. And I actually think that matters a lot because in many instances, people do have something of a tendency to mythicize nuclear weapons. It is true, nuclear weapons promise mythical levels of destruction, but the actual mechanics of nuclear weapons are not nearly as incomprehensible as a lot of the rhetoric around nuclear weapons suggests. The second reason science matters is that science gives us insight into why nuclear weapons are so destructive. And nuclear weapons cause destruction in three principled ways. The first is overpressure. Like any explosion, nuclear weapons release energy. Energy is absorbed by the air, and air therefore expands rapidly, creating a shock wave. But it's worth noting, because nuclear weapons are so destructive, they massively cause overpressure in a way that means the shock wave produced by a nuclear detonation is orders of magnitude more rapid and more destructive than the shock wave you'd get with almost any other type of weapon. Additionally, that shock wave, when detonated close to the ground, is often powerful enough to induce a localized earthquake called a ground shock, and, depending on the height of detonation, will often reflect off the ground and create a second pressure wave, usually called the Mach front. The second lethal effect that nuclear weapons generate is heat and fire, and that is often understated in assessments of nuclear weapons destructiveness. The lingering consequence of nuclear blasts for hours after the attack is that nearly everything within a lethal radius of the nuclear bomb is essentially incinerated because the enormous heat released by a nuclear blast more or less turns everything to flames. The third way that nuclear weapons destroy is essentially through what's called fallout. And this is what's most discussed within popular culture and fears around nuclear weapons. The idea of fallout is pretty simple. If you detonate a nuclear weapon close enough to the ground, when you get that huge fireball, it starts to suck in things from nearby its detonation. And what happens is lots of debris from the ground is swept up into the atomic fireball. And that fireball is filled with nasty, toxic, deeply radioactive materials, a whole mess of just chemical products that are shockingly and scorchingly radioactive. And so the debris mixes with all of that radioactivity. And when the debris falls back to the ground in whatever form or dust it takes, that debris is still very much lethal to anyone who survives the initial overpressure shockwave or fireball, because that radioactivity, causes radiation poisoning, causes a whole range of lethal physical side effects, which can have the potential to kill people for not just hours after the attack, but days, weeks, months, even years. There are numerous documented cases, for example, of people living close by to nuclear test sites, for example, in Bikini Atoll, who have developed health complexes because of their exposure to nuclear radiation. And as a matter of fact, there are well-documented cases of indigenous communities living at the Arctic poles who, as a consequence of gravitational patterns, often suffer from the radioactive residue of nuclear blasts, primarily affecting the poles of the Earth and hence causing health problems within those communities. These are the three primary ways nuclear weapons cause destruction. But it's worth noting that none of these three destructive effects are akin to nuclear extinction. So when people discuss the prospect for nuclear extinction, they probably are not describing those three consequences. What they're instead talking about is a broader fear that large-scale nuclear war involving successive nuclear blasts has the potential to greatly reduce the viability of human life. There's a couple of ways that can happen. I think the most plausible one is what's called a salted bomb, and these are also called doomsday bombs. The way a salted bomb works goes something like this. Your average nuclear bomb can be detonated in a way that minimizes fallout. Specifically, what you do is if you detonate a nuclear bomb high enough in the air, the fireball doesn't reach the ground directly enough to suck debris up into the cloud. So for example, the reason Hiroshima is livable today is because the bomb was detonated well above the ground. And although fallout happened, it did not happen on nearly a large enough scale to permanently scar the soil and the territory of Hiroshima in a way that would make it unlivable. However, if you were to build a bomb with the intention of detonating it very close to the ground and coating that bomb with metallic substances that stay around for really, really long times, what you could end up getting is multiple year or even multiple decade nuclear fallout, whereby you have bombs that detonate close to the ground and certainly cause fallout. But even worse, they cause fallout that doesn't evaporate within 48 or 72 hours. You, for example, put something like cobalt, which is a fairly long-lasting metal, into your bomb. When the bomb detonates, cobalt sticks around for years after the initial detonation, and anyone who comes in contact with that cobalt then suffers from radiation poisoning. So if you were to build one of these quote-unquote salted bombs, which as of yet no country has officially built, there is a real potential for long-term catastrophe whereby you force humanity to essentially shelter underground for many years to come. There are, of course, also other ways nuclear blasts risk existential catastrophe and collapse. Perhaps, for example, the destruction of agricultural lands renders us unable to sustain large-scale human life. Perhaps, for example, you knock out power grids, electrical connections, you disable hospitals and all of that. Perhaps the firestorms that come in the aftermath of a nuclear war release so much soot and dust into the air that you essentially block sunlight from the atmosphere for multiple years and cause a massive nuclear winter as the Earth's atmosphere climate cools considerably. So that is the science behind nuclear weapons. That is how nuclear weapons destroy. That is how nuclear weapons kill. But that doesn't give us very useful insights to the more important questions of the nuclear age. Most centrally, how did we get here? And how does the history of nuclear weapons affect their continued use today? It's useful to start by understanding just contextually World War II. And the reason it's useful to understand the context around World War II is that World War II is the place in which nuclear weapons first emerged. And I think it is worth emphasizing that the people involved in the production and ultimately deployment of nuclear weapons, their mindset and their attitude was shaped first and foremost by their experiences in World War II. And that's why it's useful to understand the historical context at play here. World War II begins on September 1st, 1939, when the German army under the command of Hitler invades Poland. Soon enough, they conquer the vast majority of continental Europe, with the exception of the Soviet Union, as the German army and the Nazis launched brutalizing blitzkrieg campaigns across all of Europe, slaughtering 6 million Jews and millions of civilians in the process. By 1940, the Germans capture Paris. Subsequently, they betray the Soviets, shirk their obligations under the Molotov-Ribbentrop Pact, and launch an invasion of the Soviet Union in the summer of 1941. On December 7th, 1941, the Japanese launch a surprise bombing campaign at Pearl Harbor in retaliation for the US oil embargoes. That subsequently drags the United States into the war. The fighting that ensues in the next 3 to 4 years is simply devastating. Tens of millions of people die, a large majority of them civilians. By 1944, the invasion of Normandy is launched. By the following spring, there is the Battle of Berlin, in which over 1 million die. Finally, Germany falls. On August 6th and August 9th, the United States deploys nuclear weapons for the first and last, as of now, time ever in human history, against first Hiroshima on August 6th, 1945, then Nagasaki on August 9th. By 6 days later, the Japanese surrender. By September of 1945, the deal is finalized. World War II comes to an end. In the midst of that process, the United States and Germany both pursue nuclearization. The Manhattan Project is the way the United States springboards itself into a position of nuclear hegemony under the leadership of both Leslie Groves as well as Oppenheimer, who has since become quite famous as a consequence of this summer's movie. This project was staggeringly massive, and it's easy to forget just how big a deal the Manhattan Project was. 10% of all electricity produced in the United States between 1942 and 1945 was rerouted to the Manhattan Project to enable the production of fissile material. This is a project that had a multi-billion-dollar price tag in the 1940s. Inflation means that that number is way more today than not. And by the end of the Manhattan Project, US nuclear scientists had successfully developed a fission weapon, but had prioritized building that fission weapon over fusion weapons, which would only come into existence many years down the road. On July 16th, 1945, just after dawn broke, the United States tested Gadget, its first ever nuclear device, in the deserts of Los Alamos. That was a test that successfully demonstrated viscerally the shocking, horrifying power of the nuclear bomb. On August 6th, that bomb was put to the test. 16,000 tons worth of force was dropped on Hiroshima. 3 days later, another bomb was dropped on Nagasaki, this time a plutonium implosion device. And the outcomes were staggering. 120,000 died at Hiroshima, at least. 80,000 died at least at Nagasaki. And these are just estimates. No one has any actual clue how many people died. The best predictions usually say 200,000 is the minimum. Probably the number is much larger. And the overwhelming, and I mean shockingly overwhelming majority of victims are civilians. Although most people did die in the immediate detonation of the bomb, very many thousands of people did not perish immediately. They died in the days and weeks and even months or years after the attack, both from radiation poisoning and the massive destruction that found both cities in the aftermath of the attacks. And it's just worth noting that Hiroshima and Nagasaki are perpetual points of debate, not within the debating circuit per se, but within debates over nuclear weapons. regardless of where you come down on the debate over whether the US was justified to bomb Hiroshima and Nagasaki, whether you are supportive of or oppositional to nuclear weapons, these bombings are horrifying tragedies no matter what side of those debates you come down on. And if you read survivors' accounts, it's truly terrifying to understand just how devastating these attacks were. These attacks are some of the worst moments of inhumanity, perhaps in human history. And in face of that shocking destruction and genocidal massacre, it's hard not to wonder how on earth the United States could have done this. And the simplest explanation, the classical explanation, is by this point in the war, August of 45, the United States was planning for Operation Downfall, which would have been the major ground invasion of Japan. And the United States and the Allied powers backing it knew for sure that were Operation Downfall to happen, the fighting would be brutal. Millions, even if not of Americans, certainly of Japanese and probably Chinese and Korean civilians would perish. And the fighting would not be easy, as battles at both Iwo Jima and Okinawa and the island hopping campaign more generally had demonstrated. In retrospect, it's not clear precisely how accurate these predictions were. Some people predict the actual casualty counts would have been well under 100,000. And the more legitimate question that's usually asked of this argument is that the Soviet invasion of Manchuria that shortly followed the bombing of Hiroshima probably was the more plausible explanation for why Japan ultimately did surrender by September of 1945. And it's easy in retrospect to say, clearly Japan surrendered because of the bombings of Hiroshima and Nagasaki, but the historical record is not clear that that is actually true. Some people then say, alternatively, there are cynical reasons the United States opted to bomb Hiroshima and Nagasaki in particular. For example, a desire to just field test these weapons and see how they performed in the heat of combat. It probably is true, with very little doubt, that certain people within the US security apparatus held and harbored those alternative interests. It's probably unlikely that the entire system writ large decided to bomb Hiroshima and Nagasaki on those grounds. So that leaves us with still the sort of core fundamental question, which is, contextually, in early August of 1945, why did the United States think it was a justified, let alone good idea, to bomb Hiroshima and Nagasaki? And I think the very fundamental and honest answer is that what the United States did at Hiroshima and Nagasaki, in a very crude and sadistic sense, was simply unexceptional in the context of the war. And this is not by any means to justify the bombing of Hiroshima and Nagasaki. These are mass killings of innocent civilians on a scale that has rarely been seen in history. But the context of World War II is important to keep in mind. This is a war unlike any other conflict to ever stain the human psyche. This war literally mobilized entire societies, every man, woman, child alive, to pursue a single purpose, which was to annihilate and eradicate and slaughter the enemy. By the time the conflict ended in September of 45, well over 80 million people had died, at least half of them, if not more, civilians. And just the degree to which countries suffered is truly staggering. 23 million people in the Soviet Union alone died. Nearly 20% of their country's entire population, a country with, to be clear, hundreds of millions of civilians in residence. Germany lost 8 million people. 2/3 of all European Jews were killed, as were Soviet prisoners of war held in Germany. Japan lost something like 4% of its entire population. Entire cities were literally razed from existence. World War II is a conflict in which the worst instincts and tendencies and proclivities of humanity were put on full display. This was the total war to end all wars. It makes World War I look like a cakewalk, and World War I was one of the gravest atrocities in human history. The reason I say all of this is by no means to say the United States is somehow justified in the context of mass slaughter to commit yet another mass slaughter. That would be a baffling and incomprehensible argument. But the reason I say this is to say, when the United States elected to bomb Hiroshima and Nagasaki, the context it was doing it in is not the modern context. And very much there were debates even at the time over the ethics of bombing peace-loving, innocent towns. But at the time, this was stated US policy. Before the United States ever dropped atomic weapons on Hiroshima or Nagasaki, the United States had firebombed 67 Japanese cities into non-existence. The firebombing of Tokyo alone on March 9th and 10th killed more people than the bombings either of Hiroshima or Nagasaki. By the time of August 1945, in other words, the United States had made very, very clear the fact it was willing to do anything and everything and whatever it took to win this war, even if that meant deliberately targeting and killing civilians on a mass scale. The United States, as a matter of fact, didn't call collateral damage collateral in the context of World War II. They called it bonus damage because that's what it was to US military strategists. The United States didn't build POW camps for Japanese prisoners of wars because it had no intent of taking prisoners of wars. And to be clear, this is not something that only afflicts the United States. If you read about what the Japanese did in World War II, or what the British did in World War II, or what the Russians did in World War II, or what the Germans did in World War II, this is a conflict where every side is just evil. This is a conflict in which every side commits brutal, heinous murder on a scale that truly cannot be understood, I believe, by a human mind. And that matters for two reasons. One, it offers us some explanation for why the United States believed that bombing Hiroshima and Nagasaki was a legitimate choice. Because coming out of 4 years of this type of conflict, the desensitization to violence and the desire to simply end the conflict through whatever means necessary, that was the dominant mindset in Washington, in Paris, in Berlin, in London, in Moscow. The second reason that context matters is the same people who ran the Manhattan Project, who managed the US Department of Defense, who strategized throughout World War II for the United States, those people were by and large the same people who influenced and determined and shaped US nuclear policy in the years and decades to come. And it's worth asking the question of, is the way we understand nuclear weapons simply the product of PTSD-ridden minds of soldiers and generals and strategists scarred by the worst war to ever affect humanity? And perhaps part of the reason the world tolerated after World War II, and to this day continues to tolerate the existence of nuclear weapons, which at the end of the day are tools of genocide, is in part perhaps because the people in positions of power making decisions about nuclear weapons were very much scarred by the memory and the horrors of World War II. And if preventing World War II required holding on to the worst instrument of death ever concocted, maybe that wasn't a bad outcome in the eyes of those strategists. So that gives us a sense of context of how the United States developed nuclear weapons, why it developed nuclear weapons, and why it opted to deploy nuclear weapons. And that context is rarely important in debate. It's rarely important even in understanding modern-day nuclear dynamics, but it will be useful for understanding the evolution of nuclear doctrine over the course of time. So that brings us nicely to the issue of nuclear deterrence and the question of how countries actually consider using nuclear weapons and why they have them. The first thing we'll chat about with respect to nuclear deterrence is why deterrence is possible. And the short answer as to why nuclear deterrence is possible is that the very destructiveness of nuclear weapons that nuclear pessimists fear is the greatest asset in the nuclear arsenal. The fact that nuclear weapons can massacre civilians, as they did at Hiroshima and Nagasaki, is the precise reason why nuclear weapons have the potential to save us from conflicts like we saw in World War II and to cleanse the world of great power war. Now, it's worth noting that we'll never know for sure whether nuclear weapons are, in fact, powerful deterrents. But what we do know is that nuclear weapons have changed the world in certain ways and in ways that we can analyze. But before we do that, the central thing we need to tackle is the issue of mutually assured destruction. It's the phrase that most people know with respect to nuclear weapons, and it's the phrase that most commonly gets brought up both in actual parliamentary debates over nuclear weapons and also more generally in policy debates around nuclear weapons. The problem is mutually assured destruction is kind of bullshit. And it's not that the theory is wrong, it's just that there are lots of questions you should ask about mutually assured destruction. Like, for example, you should probably ask whether or not mutually assured destruction is in fact assured or destructive. You should probably ask whether there are alternatives to mutually assured destruction. You should probably ask whether or not historical evidence actually substantiates the thesis of mutually assured destruction. So let's get into it. At the core of the mutually assured destruction argument is a claim about deterrence. Deterrence essentially is dissuading your enemy from doing something by threatening to do something in response. Of course, two questions naturally arise. One, what are you attempting to deter? And two, what threat are you promising? When it comes to the what of nuclear deterrence, countries broadly attempt to deter three types of actions. First, countries use their nuclear weapons to deter other countries from nuking them. Second, countries use their nuclear weapons to deter other countries from conventionally attacking them. In other words, without nuclear weapons. Third, countries use their nuclear weapons to protect their allies. For example, promising or threatening to launch nuclear weapons in retaliation if their ally is attacked. And there are, of course, different ways that threat can manifest if deterrence breaks down and you need to make true on your threat. So, for example, you might use deterrence by denial. So if, for example, you're North Korea and you are afraid of a South Korean invasion of Pyongyang, you might threaten to deny South Korea their military capacity to conquer the North by using nuclear weapons against South Korean military outposts. You might deter by threats of punishment. You might, for example, say, if you nuke me, the response you will receive will literally eradicate your country, wipe it off the map, and reduce every building inside your borders to ash. You might also deter through escalatory threats. So you might, for example, say, look, if you attack me and you don't abide by my deterrence threat, you will face hellfire, but you will face hellfire in a gradual and escalatory approach, which will increase the costs of war to you until you eventually agree to back down. And perhaps the most important element of deterrence is what's called deterrence by counterforce, which says, if you attack me, whether nuclearly or conventionally, the very first thing I will do is unload my arsenal against yours to render your nuclear arsenal incapable of offensive use. Now, it's worth noting that this very generalized and theoretical understanding of deterrence is very much a game of threats, and threats only work if they are credible. So the question that you then have to ask is, if nuclear deterrence is based on a threat, and the threat of nuclear retaliation must be credible, how can countries convince their adversaries that threats of nuclear retaliation are credible? And the short answer is countries must show, one, that they have the interest in retaliating, the will to retaliate, and second, countries must show they have the ability to retaliate. And although both of these sound easy, excuse me, they're actually both quite difficult. So let's explain how that might happen. Imagine for a moment you have a Chinese invasion of Taiwan. Does the United States have the will and ability to retaliate with nuclear weapons? Well, it certainly has the ability. The United States has a functional nuclear arsenal, and if it wanted to retaliate against China, it could. But does the United States have the will? Does the United States have the domestic political appetite to risk full-blown nuclear war to protect Taiwan from a Chinese invasion? I don't know, and no one knows. But that's the point. The United States can threaten nuclear retaliation, but no one quite knows how credible that threat is because the United States might not have the will. Suppose this time, though, the Chinese invade Taiwan with a slightly different strategy. Instead of just invading Taiwan, they also detonate a nuclear weapon over Taiwan. This time, the story changes. But at the same time, maybe it doesn't. Maybe the United States has even less stomach to utilize nuclear retaliation against China if it knows for sure it's entering a scenario of nuclear blackmail. What happens, for example, if Pakistan funds a mass terrorist campaign against India? Does India have the interest and the ability in using its nuclear weapons to destroy the Pakistani state? Honestly, it's unclear. Sure, India has the nuclear capability to retaliate. It has an arsenal, but whether or not this threat against the Indian state is so severe that India would definitively retaliate, in other words, have the will to retaliate, that very much seems up for debate. The point is, we can keep on going through a whole range of scenarios that demonstrate both what happens when a country lacks the ability to retaliate, as in this case, and also contexts where countries may lack the will to retaliate. The point, though, is several issues arise. One, in order to retaliate, you absolutely must have a nuclear weapon to launch in retaliation. That sounds trivial, sounds weird to be like, you need a nuclear weapon to be able to conduct nuclear deterrence, or nuclear retaliation rather, but it is worth noting that nuclear deterrence requires the existence of a nuclear arsenal. Additionally, it's just worth flagging from the outset that extended deterrence is plagued by problems of credibility. It's genuinely unclear whether the United States, for example, would risk nuclear escalation to protect an ally from either a conventional or, even more worryingly, a nuclear attack. But thirdly, it's also worth noting that while extended deterrence has question marks around it, the very fact that a country might have the will to use nuclear weapons might actually be enough to deter countries from aggressing against your adversaries. Because remember, nuclear weapons, as we saw before, are fundamentally a new type of weapon. So even the 10% chance that maybe the United States might nuke North Korea if North Korea were to aggress against Seoul might be enough of a deterrent against a risk-averse leader who knows that even if in 90% of cases he will survive, in 10% of cases his life will be annihilated by nuclear retaliation. But the most important takeaway, and the takeaway I want to emphasize above all else, is that nuclear deterrence depends both on will and on ability, but first and foremost on ability. And here's what I mean. Nuclear weapons are powerful deterrents, but they only offer deterrence if they can survive an attack by the enemy. If a country's nuclear weapons cannot survive an attack by the enemy, a grave problem arises. The enemy may believe it can eliminate your nuclear arsenal and avoid retaliation, because even if you have the will to retaliate, you lack the ability to retaliate. And that means that a country's threat of nuclear retaliation is only credible if the opposing country does not believe it can disarm that country's nuclear arsenal. This is the world of counterforce. What is counterforce? This is probably the most important concept in the presentation, and I think it's probably the concept that the average debater would improve the most from understanding in the context of nuclear weapons debates. Counterforce, very simply, refers to any attack which attempts or aims to eliminate your enemy's arsenal. And what that does is it eliminates the opponent's ability to retaliate with nuclear weapons. So in order to actually do this, in order to destroy an opposing country's nuclear arsenal, you need two things. One, you need to know where your enemy's nuclear weapons are located. After all, you can't destroy something if you don't know where it is. And secondly, you need an ability to actually destroy those weapons once you know where they're located. It's like the most dangerous game of hide and seek ever invented. So logically, the question that we then need to ask is, nuclear deterrence relies on countries being able to survive a first strike nuclear attack. Countries' arsenals surviving a first-strike nuclear attack depends on whether they can keep their weapons hidden from their enemies and ensure that their enemies cannot destroy those weapons. So let's examine those questions in turn. Countries usually, in fact, always, universally, keep their nuclear weapons in one of three legs of what's called the nuclear triad. And the aim of the nuclear triad is to diversify where nuclear weapons are located and how they can be delivered in a retaliatory strike against the enemy to ensure that nuclear weapons are not eliminated by an opposing country's counterforce attack. Remember, counterforce in this context just means an attack aiming to eliminate a country's nuclear arsenal. The three legs of the nuclear triad are based in the air, in the sea, and the land. Let's chat about air first. Air legs of the nuclear triad are perhaps the simplest and the easiest to understand. The idea goes something like this. Nuclear weapons are just bombs, and you can probably either attach nuclear bombs to bombers, in other words, aircraft, fly the aircraft over your enemy and drop a bomb on the enemy, or you can attach a nuclear bomb to a missile and launch that missile. Now, what is the benefit of putting nuclear weapons in the air, either on nuclear aircraft or on nuclear missiles, in particular cruise missiles? The benefit, of course, is that if you fear that your country is under attack, you can put your weapons in the air, right? So for example, if you're running a US Air Force base and you're concerned that the Russian military has just launched a nuclear counterforce attack against the United States, you can try to get all of your bombers in the air before the enemy and the enemy's incoming missiles can destroy your fleet of strategic bombers. But of course, there's a huge, huge risk here. The United States, Russia, China, Britain, France, Israel, Pakistan, India, North Korea, every country with nuclear weapons understands that their military air bases, in other words, the places where they station their cruise missiles, the places where they station their bombers, the places where they station their aircraft, are sitting ducks because everyone knows where they are and they're not that hard to destroy. So for example, the United States has a grand total of 3 Air Force bases that are capable of housing nuclear weapons. One of them is in North Dakota, one of them is in Montana, one of them is in Missouri. They're not hard to find, they're easily detected, and they're very vulnerable to enemy attacks. And on top of all of that, by the way, aircraft and cruise missiles are not perfect ways of delivering weapons. Perhaps most importantly, these weapons delivery systems are quite vulnerable to an opposing country's air defenses. For example, if you are China and you intend to launch a nuclear strike against the United States, and you send in a Chinese aircraft to do the job, there's a very real risk that US radar will detect your incoming flight, and US missile defense or anti-aircraft defense systems will eliminate your plane from the air before it has the ability to drop the weapon. So there is a real risk with aerial legs of the triad. Putting nuclear weapons either on cruise missiles or on bombers is risky because when those bombs are sitting at air bases, they are sitting ducks for the enemy to attack. So let's then chat about the land leg of the nuclear triad. The most common place countries station their nuclear weapons is underground in missile silos. Missile silos are buried deep underground. They are heavily fortified and require an enormous amount of force to destroy. And I will underline enormous. It is really, really hard to destroy a missile silo. What do missile silos actually contain? They contain, in most instances, a launch control office. That's the place where people would actually begin launch protocols to detonate or to launch a missile and ensure it detonates at the correct time and place. But they also contain weapons themselves. And usually missile silos contain what are called intercontinental ballistic missiles, or ICBMs, which are missiles that are able to fly into the atmosphere, out of the atmosphere and into outer space, and then subsequently follow a ballistic trajectory, like in physics, strike their target and detonate with high levels of accuracy. There is, by the way, another way that you can station your weapons inland, which is to station nuclear weapons on what are called TELs, or transporter erector launchers. If you ever see like a picture of a North Korean military parade, and there are those large trucks carrying nuclear weapons, that's a TEL. And what these TELs do is they carry nuclear weapons all across roads, across highways, across rugged terrain, really. And what they aim to do, essentially, is spread nuclear weapons out and keep them out of the enemy's eyesight. So although missile silos are very easy to find, it's very difficult to know where TELs are located because they could be anywhere in the country pretty much. The United States and most likely Russia no longer have TELs, at least not on active patrol. It's rumored that some countries like China may potentially have TELs on the road equipped with operational nuclear weapons in times of crisis. Of course, lots of this information is pretty much unknown. But what we do know for sure is that there are clear upsides and downsides both to using missile silos and land mobile missiles. The upside of a silo, it's wicked hard to destroy. The upside of a land mobile missile, it's wicked hard to find. The downside, though, is that each one's strength is the other one's weakness. A land mobile missile is hard to find, but once you find it, it's just a truck, and essentially that truck is not that hard to destroy. Silos are very difficult to destroy, but it's damn sure easy to find them. And in case you don't believe me when it comes to just how easy it is to find them, you can quite literally take a look, as a matter of fact, at exactly where US missile silos happen to be located. They're on Google Maps. They're quite literally on Google Earth. It is by no means difficult to find, let alone look at these things. And what that means in practice is that missile silos are not exactly concealed. They are very hard to destroy, but very much easy to identify in terms of location. The final leg of the nuclear triad is based at sea, and the way the sea leg of the nuclear triad works is that missiles are kept stationed on ballistic submarines. Quick note, nuclear-powered submarines are not necessarily armed with nuclear weapons. Usually, a submarine armed with nuclear weapons is referred to either as an SSBN or as a ballistic submarine. Now, the upside of stationing your nuclear weapons with a submarine is that you can launch the missile from the submarine in what's called a sea-launched ballistic missile, or SLBM. It works pretty much just like an ICBM, but it's able to fly up out of the water, then into the sky, then into outer space, and then come crashing down at its target. These systems are freakishly expensive. It's about $9 billion per submarine, at least in the United States. But these are the hardest weapons to find because identifying the location of underwater ballistic submarines is nightmarishly hard. And that is the huge upside of these systems. So the point is this: don't lose sight of the big picture. Countries want to use their nuclear weapons to deter their enemies from attacking them. However, nuclear deterrence only works if your nuclear arsenal can survive a disarming attack by your enemy. The way that countries attempt to increase the survivability of their arsenal against another country's preemptive first strike is by diversifying where they station their nuclear weapons. They station them at aerial bases, which can be deployed by cruise missiles or bombers. They deploy them at sea, where nuclear weapons are carried by submarine. They also deploy nuclear weapons on land, both with land mobile TELs and in fixed position missile silos. Why does that then matter? Counterforce aims to destroy each leg of the nuclear triad in order to incapacitate a country's nuclear arsenal. The question we then must ask is, how do you actually attack the aerial, sea-based, and land-based legs of the nuclear triad? The short answer is, if you want to attack another country's air-based missiles, what you want to do is to attack their air bases. So as we saw before, for example, the United States stations all of its air-based nuclear weapons at just 3 US air bases. So if a US adversary, like say Russia, had an intention of disarming the United States' nuclear arsenal, its first step would probably be to rapidly destroy those 3 US Air Force bases. What about sea? When you attack a country's sea-based nuclear leg, what you are doing is attacking their ballistic submarines. And what you have to do is to identify where those submarines are, track them underwater, and then send a torpedo or a naval landmine at them to destroy the sub. What happens on land? You need to either locate your enemy's transporter erector launchers and destroy those before they can launch. And you need to identify where your enemy country's silos are, and you need to have very powerful explosives that can destroy those silos, even though those silos are hardened and fortified against attack. The point is, you need three things to execute a counterforce operation. You need to move swiftly so the other country can't get their bombers and their missiles in the air. You need to act with intelligence because you need good knowledge of where the enemy's military assets are located. And most importantly, you need force, and you need a damn lot of it. If you're going to destroy an enemy country's silos, you need really damn powerful explosives. And as it turns out, what that means is that if you are going to destroy hardened aircraft shelters and underground missile silos, at least until a couple of years ago, really the only way to do it, counterintuitively enough, was with nuclear weapons. And there is some irony here, right? It's a little strange to think the way that you would destroy the other country's nuclear arsenal is by using your own nuclear arsenal. But that, as a matter of fact, is exactly what happens. If any country wished to destroy another country's nuclear arsenal, what they would almost certainly have to do is launch nuclear weapons against the other country's missile silos and aircraft bases. The question you're almost certainly asking yourself in your head right now is, come on, that's crazy. Why on earth would you need to use nuclear weapons just to blow up a little aircraft base or a missile silo? And the answer is because of what we saw before. Missile silos are very, very hard to destroy, but nuclear weapons are orders of magnitude more destructive. Remember, it would be really hard to fly an entire squadron of bombers over an enemy's airspace and drop thousands of pounds of conventional weapons on that airbase or on that missile silo. You probably only have a few missiles to really attack the enemy's nuclear arsenal. That means you don't have the luxury of dropping 10,000 pounds of incendiary explosives on your enemy. If you're going to attempt a counterforce attack, you have just a few shots to get it right. That is why you need to use nuclear weapons in the vast majority of cases against hardened aircraft shelters and underground missile silos. And just to be clear on what that means, counterforce means attacking the enemy's nuclear arsenal. Attacking the enemy's nuclear arsenal requires the use of your own nuclear weapons because the targets you're going after are so fortified and militarily hardened that weaker or softer explosives just won't do the trick. But how on earth are you supposed to locate land mobile missiles or ballistic submarines traversing the open waters? So, for example, to put it kind of honestly, the United States allegedly, according to rumor, which is probably credible in this context, the United States quite literally has its ballistic submarines follow a randomly generated path. Every so often, the submarines are told to generate a random number 1 through 4 that dictates the direction into which they'll next head. So it's very difficult to preemptively monitor or predict where a land mobile TEL, for example, will go, or the direction a ballistic missile submarine is headed in. So how on earth are countries ever possibly supposed to look at and identify and locate and track their enemies' mobile missiles? Honestly, I have no clue. And I don't think anyone has a great clue because the probably honest ways that countries do this is through very classified things that regular folks like myself don't know about. But most likely what countries are able to do is they are, as a matter of fact, able to track where their enemies' missiles are located because tremendous improvements in sensing technology has made possible the locating and identifying and tracking of enemy military assets. For example, throughout the Cold War, the United States made extensive use of a system called SOSUS, which weaponized hydrophones to monitor the open waters for very loud and very noisy Soviet ballistic submarines. For years upon years, the United States and its network of hydrophones was so effective, it actually was able to tail and follow every ballistic submarine deployed by the Soviet Union 24/7, 365 days a year for multiple years on end. So it is true. Identifying mobile missiles and ballistic submarines is tough stuff, but it's not impossible stuff. And in an age where intelligence gathering and surveillance and reconnaissance has literally never been easier, it is very much possible to identify the location of TELs and SSBNs. So what's the big picture? The big picture is this. Nuclear deterrence is built around your arsenal surviving a counterforce strike. Counterforce strikes involve direct use of nuclear weapons. And that has a huge implication for how we make sense of nuclear arms races. And here's how it works. A common argument that you'll hear in debates around nuclear proliferation is there is no reason countries should build up nuclear weapons in their arsenals to the point the US or Russia or even China have. We can kill the world thousands of times over. Why on earth do we need such massive military nuclear arsenals? This is irresponsible and it's irrational. And there's a certain ring to that argument, right? It's not entirely unfair or unbelievable to say, look, we don't need 5,000 nuclear weapons. We can make do with fewer. But there is a problem with this argument. And the problem is that it misunderstands why countries build up larger and larger nuclear arsenals. Because the answer is not about destroying the world, or even, to put it kind of strangely, destroying the other country. The reason countries build up nuclear arsenals is to ensure their arsenals are survivable against an enemy's first strike attack. Here's how the logic goes. Nuclear deterrence is based on credible threats of nuclear retaliation. But those threats are only credible if a country's arsenal can survive counterforce. The problem, of course, is that when your enemy attempts to disarm your arsenal, they will make use of their nuclear weapons. So the reason that matters is if you have a larger nuclear arsenal than your enemy, you are functionally safe. Because even if your enemy could perfectly locate where your missiles are, and even if they could attack with shocking speed, such that you couldn't get aircraft bombers into the air before their attack came in, your arsenal would still survive. Weapons would not be destroyed. Because if you have 100 silos and they only have 90 missiles, they cannot destroy 100 missile silos. What that therefore means is, on the flip side, if your enemy amasses a more staggeringly large arsenal than you have, then your nuclear arsenal becomes vulnerable because the opposing side can launch a disarming attack, eliminate your nuclear arsenal, and still have nuclear weapons left over to finish off whatever is remaining. What that means, therefore, is nuclear arsenal sizes have direct implications for the credibility of nuclear deterrence. If your adversary has the real ability to threaten counterforce against your arsenal, and your arsenal is insufficiently large to honestly claim it can survive that counterforce attack, you have lost the most powerful variant of nuclear deterrence. The second reason that matters is that the logic underscoring nuclear arms races indicates just how important it is for countries to retain what's called second strike capability. The idea is this: if you want to use your nuclear weapons to make the world safer, if you want to ensure that another Hiroshima and Nagasaki never happens again, you better be damn sure as a country that your nuclear arsenal can survive the opposing side's first strike counterforce attack. Because if it cannot, if the other side believes they can strike your arsenal, blow it to smithereens, and get away with it because you can't retaliate, the logic of mutually assured destruction is dead. No longer is there any assured threat that your country will be destroyed. Mutually assured destruction is rendered immobile by counterforce if counterforce is executed effectively. So what's the big picture takeaway without all of this weird terminology? If you want nuclear deterrence to work, you need to be sure that your country's arsenal is survivable, that counterforce operations will not degrade your nuclear arsenal to the point where you lack a retaliatory option. Therefore, just to recap, nuclear weapons are powerful. The power of nuclear weapons is what makes them such excellent sources of deterrence. But deterrence only works if nuclear weapons retain second strike retaliatory capability. Second strike retaliatory capability comes through the nuclear triad. But because the nuclear triad is vulnerable to nuclear attacks, in particular because targets are hardened and blast resistant, and therefore only destroyable by nuclear weapons, there is a strategic logic to the buildup of nuclear weapons. That, right there, is the core idea and the core premise behind nuclear deterrence. There is, however, a suite of questions we've yet to really tackle, and that's what we're going to tackle next. And the first central question that we need to ask, very simply, is how much deterrence is enough? And here's kind of what I mean. If you think about the theory of mutually assured destruction, or even this concept of second strike capability we've just been chatting about, there's this implicit suggestion that sometimes nuclear arsenals might not be survivable, and they might not be able to retaliate. But we're talking here in very ambiguous terms. When I say a nuclear arsenal might be destroyed, it might therefore end deterrence, what probabilities do we need to have for deterrence to work? So for example, imagine that right now you're China. You have an arsenal of around 500 or so nuclear weapons. But you know that the United States has excellent capabilities to track, monitor, identify, and potentially destroy those weapons. How confident are you that your nuclear arsenal is still able to deter a preventative US counterforce attack? Well, what if you hypothetically could know for sure that there is a 3% chance that the United States would be able to eliminate all of your nuclear weapons, and a 97% chance that at least one of your weapons would be left surviving? I think you'd feel pretty good about those odds as China. And you'd probably say, look, the United States would have to take an enormously stupid gamble if they were going to try to disarm our nuclear arsenal. But what if those numbers were flipped? What if the United States had a 98% chance, for example, of destroying China's entire nuclear arsenal, and there was just a 2% chance that China would retain some retaliatory capability? Would China feel safe? Most people's immediate reaction is, hell no. But interestingly enough, this has been China's stated nuclear doctrine for decades, going back even to the era of Mao Zedong. China has never seriously, at least until the last 2 or 3 years, intended for its arsenal to have a high probability of surviving a first strike counterforce attack. But China has found it evidently comfortable enough that so long as there is a 1 or 2 or 3% chance that at least one of its nuclear weapons survives a counterforce operation, China believes that threat is still so devastating no country would ever attack it. But this highlights the central question that we now want to address. Exactly how assured and exactly how destructive must mutually assured destruction be to achieve deterrence? For example, when people say nuclear war will never happen because of mutually assured destruction, how assured does retaliation have to be to actually achieve deterrence? I mean, for example, if you're a country with nuclear weapons, do you need to have a literal 100% ability and will and capacity to retaliate in order for mutually assured destruction to work? That seems implausible. You're never going to have a literal 100% guaranteed capacity to retaliate. So it's probably like 99.9. But how much lower can we go and still achieve deterrence? For example, if I'm a country that has one nuclear weapon, just a single nuclear weapon, and there's a really damn good chance an adversary could blow up my nuclear weapon, I probably have like a 1, maybe 2% chance of being able to assure retaliation. The probability, in other words, of mutually assured destruction, it's like 1 or 2%. Is that enough for me to deter the other country from even thinking of attacking my nuclear arsenal? Is that enough? And on the flip side, we really haven't at all asked a more simple question. When people say mutually assured destruction, what do they mean by destruction? Do they mean literally the entire country must be annihilated and reduced to radioactive rubble? Or more plausibly, do they mean the country needs to experience severe destruction in mass apocalypse? But on what scale? How much destruction must deterrence and must threats of retaliation promise to achieve deterrence. Now, you can sort of think of deterrence as operating on a two-axis plot. On one axis, we essentially have how probable, how assured retaliation is. And on the other, we have how destructive that retaliation is. And the core idea is the more probable that retaliation is, the more powerful the force of deterrence is. If you know that I absolutely will retaliate against your attack, you're deterred more than if I just think or gesture that I may be able to retaliate. And additionally, the more destructive the threat of retaliation is, and the more destructive the actual retaliation is, the more powerful deterrence is. But the key question we want to ask is, what happens when you're in that bottom left corner? When we say you have a low probability of retaliation and destructiveness of that retaliation may not be high, is that still enough to achieve deterrence? There's two ways to answer this question. One of them is the existential perspective. And the existential perspective on deterrence says you can be in that bottom left corner and be totally fine. And here's why. An existential deterrence scholar would say, look, nuclear weapons are, at the end of the day, all about fear. Nuclear weapons fundamentally aim to terrorize the enemy. It doesn't actually matter if my arsenal survives your attack. And it doesn't even matter if I would be able to or even would want to retaliate. The fact is, as long as I have the atomic weapon in the back pocket with some possibility that it could be deployed, you will be existentially terrified of ever taking any gamble, any risk, any chance of facing a single nuclear attack from my arsenal. The assured deterrence perspective, or the assured destruction perspective, goes the full opposite way. And to an assured destruction scholar, that perspective is crazy. And what they say is, no, you've got it all wrong. To an assured destruction deterrence theorist, the world is filled with danger and risk. And in particular, the biggest problem that deterrence must answer is that the type of leader who might be willing to try starting a nuclear war is clearly the type of leader who's not scared off by being in that bottom left corner. The type of leader who might threaten complete annihilation of the world is the type of leader who can only be deterred with an absolute guaranteed retaliatory threat of complete and totalizing annihilation. So to this school of thought, deterrence requires much more than just the possibility of nuclear retaliation. To this school of thought, nuclear deterrence only works if you threaten guaranteed retaliation and guaranteed destruction. Which of these two perspectives is right? No one has any idea. Both of these perspectives have legitimacy, and different countries pursue these perspectives. So, for example, Israel maintains, at least according to most declassified documents, a nuclear doctrine that is loosely called the Samson option, based on a biblical story. And the idea is that Israel says, at least informally, Israel will use nuclear weapons as a last resort. If a country or a militant group is on the brink of overrunning the Jewish state of Israel, Israel will use nuclear weapons to maintain its existence. And this perspective is not particularly assured retaliation-y. Israel's claim is not, if you do anything in the slightest against us, we will launch nuclear retaliation. We will protect the survivability of our arsenal at any expense. No, Israel's stance is pretty explicitly existential. Israel seems to believe the existence of a relatively small and potentially vulnerable arsenal is still enough to achieve deterrence. China, at least until recently, had very much a similar doctrine. Mao Zedong famously called China's nuclear weapons paper tigers. For years, as a matter of fact, China's military wouldn't even acknowledge that their nuclear weapons mattered to national security. As in, China had nuclear weapons for over a decade before military white papers started recognizing the power of deterrence that derived from China's nuclear arsenal. So China historically had a nuclear doctrine called first strike uncertainty. The idea, China's arsenal was small, it was vulnerable, it probably could not survive a counterforce attack, but China trusted that no country would seriously attempt to eliminate China's nuclear arsenal because the possibility that even one weapon would survive would be enough to destroy that country's capital city, to end its leadership, and to therefore guarantee deterrence. The United States and Soviet Union, and nowadays Russia, have a very different perspective. These countries are very much of the mindset that assured retaliation is essential, and that is why the United States and Russia are the countries with by far, by a vast margin, the world's largest nuclear arsenals, head and shoulders above any other country, including even China. So that's the first deterrence puzzle. The question we asked was, how much is enough to achieve nuclear deterrence? The short answer is different countries have different answers. But one thing I want to emphasize really crucially is that people often pretend or act that as if mutually assured destruction is this unthinkable, sort of just like dumbly obvious nuclear theory that the entire world understands and abides by. But just to be very clear, many countries with nuclear weapons very explicitly do not have a mutually assured destruction doctrine. Pakistan does not. India does not. Israel does not. North Korea does not. There are many countries with nuclear weapons that very explicitly do not appear to believe, at least in their own nuclear postures, in the necessity of mutually assured destruction. There are many countries, Israel is one of them, that seem to believe quite legitimately that you do not need assured destruction as the basis for deterrence. You just need the possibility of retaliation. The second question that we'll then ask in relation to the deterrence puzzle is why nuclear weapons deter war. And I know that sounds weird, because are nuclear weapons just obviously deterrence? They're so destructive. Clearly, they have to be deterrence. But here's the issue. When we talk about nuclear deterrence, we usually implicitly aren't talking about nuclear weapons deterring the use of other nuclear weapons. And it's not that that's not important. It is. It's more that whenever we discuss the relative merits of nuclear weapons, we don't much care about whether nuclear weapons deter other nuclear weapons, because that's solving a problem that nuclear weapons created. What we really care about is whether or not the existence of nuclear weapons reduces the number of non-nuclear wars. And most importantly, what we're very curious in is, does the existence of nuclear weapons reduce the prevalence of highly destructive wars between large powers? But it's worth noting that this argument is not actually self-evident. We'll explore the evidence for it in a bit. But before we explore the evidence for this, what we're probably going to chat about as a necessary precursor is the logical explanations for why nuclear weapons might deter non-nuclear war. There are two broad hypotheses that people tend to offer as to why nuclear weapons deter non-nuclear or conventional war. The first is an appeal to the destructiveness of nuclear weapons. And the argument goes something like this. War is a game, and leaders only play the game of war when logically they stand to gain. And leaders stand to gain from war when the risk-weighted benefits are greater than the risk-weighted costs and the innate costs of war. And to put that a little bit more tangibly in human terms, leaders go to war when they believe they can win and the costs of war are not enough to offset the gains. And therefore, according to this logic, nuclear weapons must deter conventional war because nuclear weapons are so destructive, so harrowingly evil, that in no possible world could a leader look at the game of war and say, I stand to gain more than I stand to lose, therefore, the destructiveness of nuclear weapons must be the source of their deterrence. This is a very bad argument. And the reason it's a very bad argument is not because the logic is wrong. The logic is completely fine. The problem is that this argument only looks at history beginning on July 16th, 1945, the day the United States tested the first ever nuclear weapon at Trinity. But if you look at history well before the nuclear era, you will start to question the logic of this argument. So let's go back in history and ask a simple question. Have nuclear weapons significantly improved the destructiveness of war? And to be clear on what I'm asking, nuclear weapons, without any doubt, are vastly more destructive than any weapon ever created. But are nuclear weapons a fundamentally new chapter in the history of war? War as a story of destruction? And the answer is almost certainly no. It's worth remembering that nuclear weapons came in the immediate aftermath of the Second World War. And if you could rewind the clock to August of 45 and stop the United States from dropping the bombs on Hiroshima and Nagasaki, World War II and the way it would be remembered would be no different. World War II was a brutal war in which 80+ million people were killed. But 99.9% of them were not killed with nuclear weapons. They were killed in extermination camps. They were killed in cities. They were killed on the streets. They were killed in fields. They were slaughtered in battle, in combat, in all stages of life. World War II is the war in which nuclear weapons entered human existence. And it's true that nuclear weapons marked a turning point in conflict, but they did not mark a turning point in conflict in the context of destructiveness. World War II alone was so unfathomably destructive, even without nuclear weapons, that you should really be skeptical that we needed nuclear weapons to make war society-destroying levels of evil. But just to be clear, World War I is not the only evidence for that. Just look 20 years back at World War I, a conflict that killed, by most estimates, well over 30 million people, and the trench warfare that you saw in World War I, the use of biological and chemical weapons, the massacres of millions of people across Europe, is further evidence that war's long history of bloodshed did not meaningfully change when nuclear weapons entered the fold. Yes, nuclear weapons changed the tactics of war, they changed the strategic calculus of war, but destructiveness as a raw concept, that's not where nuclear weapons affected change. For literally hundreds, thousands of years, humanity has gone to war in the most brutal of ways. If you read about hand-to-hand combat and the way that medieval militaries fought on the battlefield, your stomach will turn upside down. The conflicts fought well prior to even the age of gunpowder are disgustingly horrible. The type of destruction that you saw 100 years ago, 500 years ago, 1,000, 2,000, 10,000 years ago, it truly is repulsive. I mean, if you look quite literally at the bones of the earliest known human civilizations, not even civilizations, but hunter-gatherer tribes, human bones show elements of violence, of other humans literally clubbing them to death with sticks and stones and other bones. The point is, war, violence, conflict, destruction has always been a central element of human society. And the suggestion that nuclear weapons marked some radical turning point in exactly how destructive nuclear weapons are is simply nonsense. There's a slight variation, though, of the argument that you'll sometimes hear. And the argument that you'll sometimes hear goes something like this. The argument says, okay, maybe nuclear weapons didn't fundamentally make war more destructive, but they made war more destructive for leaders. Never before in history did leaders personally bear the consequences of their failed campaigns on the battlefield. Nuclear weapons made sure that the elites, too, suffered. This argument demonstrates a very poor understanding of what happened to the leaders of conflict. If you think, for example, about what happened to medieval kings or tribe leaders who lost conflicts or wars, they did not face a non-humiliating fate. They were usually routinely tortured and executed publicly. Just think about the last 100 years alone. The Romanov dynasty that ruled over the Tsardom in Russia, brutally murdered at the end of their lives. Nazi leadership in Germany at the end of World War II preferred shooting and killing and poisoning their own spouses and children and pets, and then taking their own lives in bunkers underneath Berlin, rather than face the horror of what the Red Army promised them as Stalin marched on Berlin. If you think even more recently about a figure like Saddam Hussein and the fate he met in late 2006, executed by US forces, this is what happens to leaders who end up on the losing side of conflict. The point is this. People who say nuclear weapons deter conflict because they're so destructive don't fully appreciate that war was already as destructive as it could imaginably be prior to the introduction of nuclear weapons. What you're thinking in your head right now is, wait, earlier in this lecture, we saw how asymmetrically and unusually powerful nuclear weapons are. Isn't that a contradiction? No, it's not a contradiction, because the point is not that nuclear weapons aren't destructive. It's that the marginal increase in the destructiveness of war provided by nuclear weapons hardly registers. The other reason, though, we know that this cannot be the source of deterrence arising from nuclear weapons is that clearly the raw destructiveness of conflict was never the determining limiting factor in whether or not countries would go to war. If it was true that destructiveness and destructiveness alone was the predominant factor influencing leaders' assessment of whether going to war was or was not worth it, we would expect to see vast reductions in conflict well prior to 1945. But the fact that great power wars were fought with considerable frequency, that countries would routinely go to war over even the smallest of matters, suggests that the destructiveness of war as a revealed matter of humanity's preference was never really what made us go or not go to war. There's a better argument, though, as to why nuclear weapons increase deterrence. And the argument is built around the stalemating power of nuclear weapons. And there's an interesting analogy here to chess that I think can be fairly interesting. In the game of chess, the queen is, with little contestation, the most powerful piece on the board. And having your queen changes the game. But here's what's interesting about the queen. What's interesting about the queen is that her mere presence on the chessboard changes how you play, changes your strategy. It doesn't matter if she's never used or doesn't move or stays locked where she was at the beginning of the game. The point is that the queen has power in a way no other piece on the board does. And the option to use that queen to move her in a strategic way changes the balance of a chess game, even if the queen is never used. That same principle lies at the real heart of nuclear deterrence. And the argument goes something like this. Nuclear weapons are atomic queens. And the reason nuclear weapons act like queens do in chess is because they make war a fundamentally different game. And it's not because of their destructiveness. It's rather because of who takes advantage of them. Throughout history, humanity has developed and produced and manufactured dozens and hundreds and thousands of ever more powerful weapons. And the reason we built all of those weapons was for a simple reason: to help strong countries win wars. Nuclear weapons function a little bit differently. The countries that make the greatest use of nuclear weapons are not strong countries. Nuclear weapons benefit instead weak countries. Think about a simple example. What country in the world right now enjoys and supports nuclear weapons the most? A lot of people's immediate instinct is to say the United States. The United States is, after all, a neo-imperial colonial military power and all of that. But the United States, in truth, is not the world's cheerleader of nuclear weapons. If you could rank countries by what countries like nuclear weapons the most, it's actually the weaker countries. North Korea is thrilled with its nuclear arsenal because suddenly a small country with the GDP of Hanover, New Hampshire, and a military armed with 1980s grade weaponry that would literally be flattened in 3 weeks by the forces of South Korea or the United States, or hell, even China, is somehow able to act with global impunity because it possesses nuclear weapons. Pakistan is dwarfed in comparison to the Indian National Army, but Pakistan knows and acts very much so like there is 0% chance of any Indian regime ever invading Islamabad. Why? Because although Pakistan is the weaker of the two countries, its nuclear arsenal balances the playing field. And here's why North Korea, Israel, Pakistan, any number of countries facing some form of military disadvantage find such power in nuclear weapons. Nuclear weapons make war unwinnable Because nuclear weapons are able to inflict mass destruction on the winning country when victory seems inevitable. This is the distinction between conventional and nuclear war. In a conventional war, once a power starts to lose its grasp, and once it heads for defeat, the war is all but over. And although you'll have many more months, maybe even years or decades of fighting, the conflict's outcome is decided, and the powerful country must just push its advantage and force the other country into defeat. Nuclear weapons are different because even when the weaker country appears outnumbered beyond imagination and stands zero chance of winning the war, nuclear weapons give them an atomic queen. The threat, even just the threat that I will drop a nuclear bomb, even as you force my hand to sign a peace treaty signing away my sovereign territorial rights, that threat is fundamentally new in military statecraft. Never before has any weapon given such power to weak, overpowered, outnumbered, outgunned, cornered states. And the deterrence power of nuclear weapons is therefore in stalemate. Nuclear weapons create stalemate by making war unwinnable for either side. No country can ever win a war against a nuclear power because nuclear weapons ensure that no matter what gain you would have by defeating that nuclear power, the nuclear retaliation you will suffer will inevitably wipe out whatever gains you hope to get. When people criticize nuclear weapons, they usually criticize nuclear weapons for having overkill power. People say nuclear weapons are irrationally unnecessary because we can already kill the world many times over. They mean overkill quite literally. But the real power of nuclear weapons is not in overkill. It's in mutual kill. It's the ability for a nuclear-armed state to ensure the destruction of its enemy even when it loses the war on the conventional battlefield. And nuclear weapons are unique because they're very difficult to find, they're very easy to deliver, and they're extremely destructive per each unit. War doesn't become more destructive because of nuclear weapons. War becomes unwinnable because of nuclear weapons. That answers the question, logically at least, of why nuclear weapons might deter war. So let's put the theory to the test. Does the stalemate theory of deterrence hold up under historical and empirical scrutiny? And there are 5 pieces of evidence that suggest, yes, nuclear weapons have fundamentally revolutionized international politics in a way that makes the world safer. Let's go through all 5. First, in the 100 years prior to 1945, the world 5 times over engaged in great power wars. It first happened in the Crimean War, then again between France and Prussia, then the Russo-Japanese War, and then the 2 world wars. Hundreds of millions of people died across those 5 wars. And those 5 great power wars between great powers all happened in just a century prior to the invention of nuclear weapons. In all the decades since the invention of nuclear weapons, we have not seen a single great power conflict. Yes, we've seen the Cold War, we've seen proxy conflicts, we've even seen minor forms of conflict, like border skirmishes, for example, but we have not seen a great power war since the end of World War II. Second, countries that lack nuclear weapons continue to engage in conflict with other countries lacking nuclear weapons on a scale of destructiveness that resembles the pre-nuclear age. The African Civil War, the African World War, for example, of the First Congo War in the 1990s, killed well over 3 million people. And it's very plausible that that conflict may, arguably, have been less plausible had, for example, the Congo or perhaps Rwanda possessed some form of a nuclear monopoly. Third, when nuclear countries do fight war, they typically fight it against other countries, even without nuclear weapons, in a very different way than they usually would. They don't use nuclear weapons. Never have they since August 9th, 1945. Fourth, even when nuclear powers fight wars, they no longer fight wars with the intent of conquering the enemy. That's why India and China will fight border skirmishes, but never a full-blown war of invasion. It's why India and Pakistan will trade barbs over accusations of state-backed terrorism and trade bullets at the zone between the two countries, but they will not go to full-scale war. The final piece of evidence is the sort of North Korea piece of evidence, and it's perhaps the most uncomfortable piece of evidence in favor of the nuclear peace argument because it demonstrates very clearly one of the major downsides of nuclear weapons, which is authoritarian or rogue regimes in possession of nuclear weapons are treated markedly differently than very similar regimes that lack nuclear weapons. The sorts of things that the North Korean regime has done in the last 20-odd years and faced all but essentially a slap on the wrist for internationally in the context of sanctions or condemnations is staggering. And why has North Korea not faced stiffer penalization from the international community? Simplest reason, they have nuclear weapons, and no one's going to irritate a country with nuclear weapons like North Korea, despite the fact that it acts in a way that does not deserve caution in the eyes of most international powers. The point is this: nuclear weapons create deterrence via stalemate. Unlike every other weapon ever invented in history, nuclear weapons are tools of the weak. And that is why decisive force against nuclear-armed states is unthinkable. There's an interesting example of where this applies that I think is strangely miscovered in most debates about nuclear weapons. And frankly, if you have a generic debate like this House regrets the invention of nuclear weapons, this probably should define about half of the debate. Because whenever people talk about nuclear weapons, they almost always talk about great power conflict in a very abstract way. Like, would the US and Soviet Union have fought a war in the absence of nuclear protection? And people speak about this like it was this distant prospect that no one seriously considered. That's factually not true. And the immediate aftermath of World War II is the best case where we can apply this logic. In the immediate aftermath of the Second World War, the Soviet Union was orders of magnitude more powerful than the United States or Britain or what would soon become NATO in Western Europe. There's this great excerpt from a report declassified several years back that made quite clear that, in essence, the Soviet Union possessed literally hundreds more military divisions across Western Europe. And if the Soviets seriously intended to wage war against Europe, they almost assuredly could reach the Suez Canal. They were that powerful. And this is a weird perspective because when people think about the US military or NATO in the Cold War, there's often the suggestion that there was a balance between the United States and Soviet Union, that these were two countries that were matched toe-to-toe and simply never went to nuclear war because of nuclear deterrence. That's not true. For the first many decades, as a matter of fact, after the Second World War, NATO paled greatly in comparison to what the Soviet Union possessed. And in fact, it paled so much that the United States knew it would have no shot at all of winning the conventional war against the Soviet Union. And what are now declassified war plans from US strategic planners in Washington and the Pentagon, these plans make very clear if the Soviet Union invaded Western Europe, the US strategy was to withdraw from Western Europe and begin dropping atomic bombs on Soviet forces and Soviet cities. And yeah, it's crazy. But the reason this happens is not particularly unthinkable. The United States, in the context of the initial Cold War, faced mass conventional disadvantage. Just like we were talking about earlier, nuclear weapons are tools of the weak. The United States was the weak force at the beginning of the Cold War, and the United States knew it damn well. If you read what are now declassified communications between secretaries of state, secretaries of defense, even sitting US presidents, they all make clear no one had any hope whatsoever the United States would be able to win the conventional war against the Soviets. The Soviets outnumbered them, they had better technology in many contexts, and their economy was sufficiently large enough to support a mass war that would decimate Western Europe. This right here is quite literally the document that the United States had on its books for decades, which made very clear that the United States would deploy nuclear force, hundreds of nuclear bombs, thousands of nuclear bombs against the Soviets in the event that the Soviet Union exercised its conventional advantage over the United States. Everyone talks about the Cold War now in the context of it's so good we avoided a nuclear war, and that's obviously true. It's perhaps even scarier to think that very plausibly the world was on the precipice of the Third World War, where the United States and Soviet Union went to war in a context where the United States almost assuredly would have been eviscerated. And that's why whenever people make statements like, no country would ever consider a nuclear war, everyone knows mutually assured destruction works, you should kind of be skeptical. Like, it's intuitive that mutually assured destruction works, but these documents are living proof that countries think about nuclear weapons this way. And by the way, this is not the only country to have ever thought about nuclear weapons in this context. This theory of using nuclear weapons when you have a conventional disadvantage, it's how Pakistan currently thinks about their nuclear weapons. It's how North Korea thinks about their nuclear weapons. It's maybe even how Russia is beginning to think about its nuclear weapons, possibly even the same for Israel. The world has 9 nuclear weapon states. 4, maybe 5 of those countries all view nuclear weapons in a way very similar to how the United States did at the beginning of the Cold War and the beginning of the nuclear arms race with the Soviets. We cannot win war on the conventional battlefield. Nuclear weapons are our best shot. That leads us then to a very important question. If the United States was willing to plan so extensively for a nuclear war with the Soviets, knowing it couldn't win the conventional war, nuclear deterrence clearly is not bulletproof. Clearly, nuclear deterrence might fail. So let's explain why. And a natural place to start is to note empirically that nuclear deterrence does not enjoy complete empirical backing. It's hard, for example, to explain why China invaded Korea in 1950, knowing very much it would incite retaliation by a nuclearly armed United States. The same is true in the context of the numerous border skirmishes, the most perhaps consequential coming in 1969 between India and China, 2 countries that would later possess nuclear weapons, and at the time, so too did China. And perhaps most importantly, the 1973 Yom Kippur War is maybe one of the greatest question marks on the nuclear deterrence argument. Just as a brief recap, on October of 1973, Anwar al-Sadat's Egypt launched a surprise invasion in conjunction with Syria into Israel, aiming to recapture the Golan Heights in what used to be Syria, now Israel occupied since the 1967 Six-Day War, and seize control of the Sinai Peninsula in former Egypt. To be clear, the Israeli government has never publicly acknowledged their nuclear weapons, but it was well known that Israel possessed nuclear weapons by the late 1960s, probably 1967 for that matter. 1973 is at least 4, maybe 5 years after both Egypt and Syria knew for sure Israel had an operational nuclear arsenal. And yet still, on Yom Kippur Day, Syria and Egypt launched a brazen attack against Israel without provocation. This attack raises serious questions individually about the strength of the nuclear deterrence argument. 2 very much rational leaders in Assad and Sadat opted to invade a nuclear power without nuclear deterrence themselves and without the protection of a nuclear umbrella. The Soviet Union almost assuredly would not have provided nuclear coverage to these 2 countries. Does that mean that nuclear deterrence is shattered as a theory? No. But what it does mean is that nuclear deterrence does not prevent all conflict. Nuclear weapons probably do deter the use of other nuclear weapons, and they probably do deter full-scale war whose intention is eradication of the enemy. But nuclear weapons cannot deter any and all forms of conflict in whatever form they may take. The second problem with nuclear deterrence is that nuclear weapons are an insufficient deterrent. And why do we know that's true? If you are even somewhat of a realist, then you should believe that countries act to pursue their own security in an anarchic international environment. But there's a worthwhile question that we should raise here. If countries act primarily or predominantly to protect their own security, then many international actions reflect states' insecurity about their own security dilemmas, their fear that they may not be secure. And that's why historically countries engaged in arms races with conventional adversaries. It's why they fought wars over strategic territory. It's why they grew concerned when their enemies' economies grew large. And it's why they formed vast multilateral alliances for military protection. These types of behaviors are signals that countries do not believe they are secure. Now, when countries acquire nuclear weapons, they acquire a nuclear deterrent. Logically, they should no longer have existential fears for their own security, and therefore they logically should have very little reason to do any of these things. But countries continue to engage in arms races, even after acquiring nuclear weapons. They still care deeply about relative gains of their adversaries. Think, for example, about how deeply paranoid the United States is about the growth of the Chinese economy since the reformist era of the 80s and 90s. Why do countries still engage in such vast buildups of conventional weapons, or even nuclear weapons for that matter? The point is, nuclear weapons are a deterrent, but they are not the deterrent because countries do not behave as if there is a fundamental revolution in international statecraft as a consequence of nuclear weapons. The third problem with nuclear weapons and the deterrence effects they offer is that nuclear weapons may not be the only deterrent game in town. Remember, there are many reasons to believe conflict may have declined since the end of the Second World War. Maybe the rise of democracy has something to do with it. Maybe the rise of international organizations, or the liberal world order, or norms which heavily discourage conflict, or the proliferation of free trade and the integration of the global economy. Maybe the memory alone of the horrors of World War II is enough to deter countries from ever going to war again. Now, lots of people often make this argument, and they make it a little bit too much. Perhaps they say nuclear weapons add zero to the deterrence puzzle. We absolutely do not need nuclear deterrence. That is, to some extent, a bit disingenuous. There have long been trends in international politics towards reduction in conflict, including things like partial democratization of power, partial internationalization of disputes between countries, or partial integration of economies, even via more forcible mechanisms like colonialism. And yet, historical advancements rarely ended great power conflict. So it's probably untrue that alternative trends can single-handedly explain the reduction in great power war since the end of World War II. However, if we are assessing the relative benefits and costs of nuclear weapons, it is just worth noting that nuclear weapons are not the only reason to believe that conflict may no longer be all-encompassing. The fourth problem with nuclear deterrence is its ambiguity, because it's very clear in some cases that nuclear retaliation will occur. If I launch a nuclear attack against you, you will launch a nuclear attack against me. No one doubts that or blinks an eye at that thought. But there is a problem. What happens when you are trying to deter something other than a nuclear attack? Imagine, for example, the United States launched a small-scale drone attack against Chinese military facilities along the Taiwan Strait. Would the Chinese government respond with a nuclear retaliation? Probably not, but I don't know. If you don't think so, and I don't think so, the logical question to then ask is, where would the red line be? How much damage would, for example, the United States have to inflict on China, or China have to inflict on the United States, for either country to view nuclear escalation as in its natural interest? And so in this way, there's a strange paradox around nuclear weapons. One, no one really knows when nuclear weapons will or will not be used. And in that way, it's very difficult to have credible threats that any form of conflict will be met with nuclear vengeance. But secondly, there's another paradox around nuclear weapons. Ideally, we would never want nuclear weapons to be used. We know what they do to this world, and it is horrible. But at the same time, we cannot actually have nuclear weapons have a objective 0% probability of use or deployment, because that would eliminate the deterrence capability. So in order for nuclear weapons to stabilize the world, Churchill, after all, famously noted that the flip side of terror is stability. The way that you, in many instances, prepare for peace is by preparing for war. Deterrence itself is a paradox. There's another problem, though, with the ambiguity of nuclear deterrence, which is that extended deterrence, for example, the United States offering a nuclear umbrella to countries in Western Europe or NATO, extended deterrence is not particularly credible. The French president, Charles de Gaulle, probably said this best. The way he put it was, the United States very well may not risk a nuclear exchange with the Soviets, which would almost assuredly kill tens of millions of Americans, simply because it was responding to an attack against Western Europe. The United States, in other words, would not risk its own skin to save its European allies. And that's the central problem with extended deterrence. The fifth problem as well with the argument about nuclear peace is that it simply is not universally applicable. The premise of nuclear deterrence as an argument tacitly assumes the other side's leadership is rational. They assess costs and benefits in the same ways that you do. So when you threaten, I will nuke your country out of existence, they respond to that threat as you intend. But it's very plausible, just as a note, that that doesn't actually happen with some leaders. Some leaders may, for example, pursue non-worldly ambitions. They may believe that the destruction of their country is a worthwhile price to pay for whatever their end goal is. They may, for example, care more about ideology than they would care about their own life. And there may be some leaders who are so aggressive and so risk tolerant that they very well may act so hawkishly that they will use nuclear weapons, even when that does mean they will face near guaranteed destruction in return. And of course, terrorists are uniquely difficult to deter. I mean, imagine ISIS launched a nuclear weapon against, say, France. Who does France target its retaliation against precisely? ISIS is an idea more than it is an organization. And for as many ISIS militants as there are, launching a nuclear retaliation against every suspected ISIS base in the world just further causes the idea to spread, not ends ISIS as a terrorist entity, which means deterrence does not work against all actors in all contexts. The sixth problem with deterrence is the stability-instability paradox. The idea is that nuclear weapons are too good at what they do, and deterrence is so powerful, it actually undermines itself. The idea goes like this. Typically, border skirmishes are irrational because countries are afraid that if they start a border skirmish, the border skirmish will not end as a border skirmish, but instead will escalate to a full-blown war in which their country will suffer massively. And therefore, in the absence of nuclear deterrence, countries have strong disincentives to engage even in low forms of conflict for fear of escalation to the mass total conventional level. However, nuclear weapons make that fear go away, because you know that no country that you are fighting a small-scale dispute with will escalate to the fullest scale of war, because that would risk nuclear escalation. And that means that small-scale conflict is counterintuitively safe, because you know the other side certainly, almost certainly at least, won't use nuclear weapons in response to something like a border skirmish. And you also know the other side won't escalate the war on the conventional level. It won't send more tanks. It won't send more troops. It won't quadruple the size of its standing army, because it knows if it does any of those things, it risks conventional war leading to nuclear war. And in that way, the stability offered by nuclear weapons destabilizes the world by increasing the logical benefit of engaging in small conflicts. So in sum, there are 6 reasons to believe that deterrence is not everything it's cracked up to be. It can't deter all forms of conflict. Clearly, nuclear weapons do not change countries' behavior as much as we might think. Nuclear deterrence is not the only game in town. Nuclear weapons struggle to establish credible threats against non-nuclear aggression. Nuclear weapons are not universally valuable, and nuclear weapons, in many instances, are more destabilizing than they are stabilizing. But there's one much more, at least in my opinion, important way that deterrence fails. And it's the most, in my opinion, most cataclysmic way that nuclear war begins. And it goes something like this. Consider for a moment the war in Ukraine. And consider a hypothetical situation. Imagine that it's mid-2024. Ukraine is deep into a second counteroffensive. But this time the counteroffensive is making tremendous progress. And Ukraine pushes deep into Russian-held territory in Ukraine proper. Ukraine begins launching drone strikes and artillery attacks and missile strikes against the Kerch Strait Bridge, which connects Russia proper to Crimea. Within weeks, assume, for sake of this hypothetical, that Ukraine successfully cuts off Russia from Crimea. Russian forces are thus cut off from supply chains. They find themselves outnumbered and overpowered and under-resourced. Crimea falls back into Ukrainian possession for the first time since its illegal annexation in 2014. Can Vladimir Putin survive the loss of Crimea? To put it a little bit more concretely, would Vladimir Putin fear that losing Crimea is a loss so humiliating his own power would be on the line? He may be ousted in a second coup, but this time, instead of the Wagner group in Prigozhin ending in a standoff sending off to Belarus, in this case, Vladimir Putin loses his life and his power. Or maybe Putin fears that such a devastating, humiliating defeat at the hands of the West may, in fact, delegitimize his regime in the eyes of the Russian people. And Putin might fear for his own life in that context. Here's another example. Take the situation in Taiwan. Imagine it's the summer of 2027. It's the 100-year anniversary of the People's Liberation Army of China, and Xi Jinping officially orders the PLA to begin the invasion of Taiwan. But Taiwan resists powerfully. It repels the initial invasion. It detects China's submarines and destroys them with its newly acquired torpedoes. Taiwan's indigenous Skybow anti-missile defense system decimates the Chinese Air Force. The US deploys the 7th Fleet to protect Taiwan. It eliminates and excoriates every Chinese vessel to step foot within the Taiwan Strait. And within 48 hours, the United States receives legal authorization from South Korea, Japan, and the Philippines to stage military operations from their bases to destroy the Chinese Navy. And imagine at the end of all of this, 3 weeks into the invasion, China finds its Navy destroyed, its Air Force underwater, its army humiliated, and Taiwan not just severed from China with the invasion failed, but Taiwan so empowered by its victory that it finally declares independence backed by a victorious West. Can the CCP survive this? Remember, the CCP has spent years championing the narrative of Taiwanese unification. Since Mao Zedong proclaimed the existence of the People's Republic of China on October 1st, 1945 in Tiananmen Square, the narrative of the CCP has been built around restoring China to greatness after the century of humiliation began in 1839 with the First Opium War. This is a party that frames itself and frames its legitimacy around greatness and power and strength, and overcoming the Western powers that historically have divided and excoriated China. Does the CCP anymore have legitimacy in the eyes of its own leadership, in the eyes of its own military, in the eyes of its own people? I don't know. Imagine one more example. Imagine this time we go to the Korean Peninsula. Suppose that North Korea launches a military campaign into South Korea, but Kim Jong-un miscalculates badly. Within mere hours, the United States and its forces in South Korea, working in conjunction with the Republic of Korean Army, repel that attack. Within mere hours, the Combined Forces Command counteroffensively marches on Pyongyang. They surround the capital of North Korea. Does Kim Jong-un believe he can survive the siege of Pyongyang? And just for reference, by the way, This is what happens when the United States invades countries to their leaders. In 1989, the United States invaded Panama. What happened to Noriega? He ended up in prison for the vast majority of his remaining life. What happened after March 19th, 2003, when the United States bombed Baghdad and began its invasion of Iraq? Saddam Hussein was hanged in the basement of a US military compost in Baghdad and jeered publicly by US masked soldiers as he fell through the gallows. What happened after NATO began its military operations in Libya? Short answer, Muammar Gaddafi was forced into exile in his own country, found cowering in a water pipe, and executed on live video. What happened in the 1990s when the United States and its NATO allies began the mass bombing campaign against the Yugoslav Republic led by Milosevic? Milosevic was detained by 2001. He was extradited to The Hague. He died in prison. This is what happens to leaders who fight wars against the United States or against US allies. Why does that matter? Mutually assured destruction is the core reason people say we don't need to worry about nuclear war. But there's a problem. Mutually assured destruction in peacetime is different than mutually assured destruction when conventional war has begun. And the central problem the world has yet to face is what happens when a nuclear power faces conventional defeat on the battlefield, not just in a way that is bad tactically, but what happens when a regime faces defeat so bad, so destructive, and so humiliating, the regime fears that conventional defeat will mean the regime's death. How do you convince that regime it should not pull out its most powerful weapon in a last-ditch bid to stave off defeat? Zelensky was asked shortly after the war began whether he fears that Putin will use nuclear weapons in Ukraine. And he said no, and this was his logic. Zelensky said, look, Putin is not going to use nuclear weapons because he loves life too much and he fears death too intensely. And he knows, Putin that is, knows, that if he uses nuclear weapons, the world will retaliate against him with shocking force in a way that means he will feel the consequences and wish he never used nuclear weapons. Here's the problem. That's probably not what Putin's primary concern is right now. There's a great excerpt from William Burns, the current director of the CIA, from his memoir about a broad concern relating to Putin's thoughts on nuclear escalation. Burns reveals in his memoir that there is credible intelligence that suggests Vladimir Putin is obsessed with watching two videos that are both publicly accessible. You can look them up, although they are quite gory, fair warning. The first video is the video of Saddam Hussein being executed in 2006 by US forces. The second video is the video of Gaddafi being brutally assassinated by rebel insurgent forces in the aftermath of the 2011 NATO bombing campaign. What does that reveal about Putin? What does it suggest that Putin spends many hours just watching, literally in his mansion, just watching videos of two of the most famed dictators in recent history dying in the aftermath of a war they lost brutally? What it suggests essentially is there is a real risk that a leader who faces a devastating defeat on the conventional battlefield will worry psychologically that defeat on the battlefield will result in their own death, or even if not in their own death, in their own downfall from power and the destruction of their regime and their ideology and everything they hold dear to them. This is the biggest threat to nuclear deterrence, and it has nothing to do with mutually assured destruction. Imagine for a moment we go back to the Korean example. The Kim dynasty faces an invasion at the hands of the United States. Here's the issue. Most people would say, don't worry, North Korea won't go nuclear because mutually assured destruction exists. And the argument they're making is North Korea will never go nuclear because North Korea knows its leadership will die if it uses nuclear weapons. But here's the problem. Whenever people make the mutually assured destruction argument, they leave the counterfactual implicit. What people implicitly say when they make the mutually assured destruction argument is Kim Jong-un would never escalate to the nuclear level because if he did, he would die. And if he didn't, he would not die. But if you're Kim Jong-un and you're 28 hours or 24 hours away from being captured, arrested, detained, and eventually executed by the US military backed by South Korea, that's not the option you face. The option is not use nuclear weapons and die or don't use nuclear weapons and live. The option you in the moment believe you face is use nuclear weapons and maybe die because the United States will retaliate, or don't use nuclear weapons and almost for sure die because you are going to be incarcerated, convicted, and executed. So what might North Korea do in this situation? Kim Jong-un faces conventional defeat on the battlefield, and he believes conventional defeat will spell the end of his regime and the end of his life. Might it not be in North Korea's strategic interest to deploy a nuclear weapon, to, for example, drop a 20-kiloton nuclear weapon on a US military base in Japan or South Korea, or even against a US naval fleet in the South China Sea? What might that do? North Korea drops a nuclear weapon. It says the United States and South Korea must back off immediately, or else we will continue dropping nuclear weapons on your people. In that situation, there is a chance the United States responds with nuclear weapons. But if you're Kim Jong-un, that's a threat and a risk that you'll take because the outcome for you is death. And the outcome you were always facing, psychologically from your perspective, remember, these are paranoid dictators, the perspective that you have is you were always going to die. So that doesn't scare you that much. But there is a real chance, based on everything we've seen for the last hour, that deterrence won't happen, that retaliation won't come, that extended deterrence is too shaky of a theory for it to work, and you might actually escape having blackmailed with nuclear weapons your way into security. This is obviously not an optimal outcome, but if you're North Korea and you fear your own destruction, this is much better than the status quo. Imagine this applied in the context of Ukraine. Imagine, for example, that Russia fears that Crimea will be captured by the Ukrainians. This would be a massive victory for Ukraine. And I think every good-hearted person out there would celebrate tremendously that accomplishment, as would the Ukrainian people, as would Volodymyr Zelensky. The problem, though, is that Vladimir Putin might, in his paranoid mind state, surrounded by a sycophantic yes man, think the destruction of Russia's ownership of Crimea is the last straw of my regime. I will not survive the military coup that will get me in 12 hours. And if a military coup doesn't get me in 12 hours, the Kremlin and the oligarchs I rely on will oust me in 24. And if the oligarchs aren't responsible for my dismissal from power in 24 hours, mass popular protests I simply cannot quell in the next 36 hours will assuredly have my head. And if that is the thought running through your mind as Vladimir Putin, you might very well decide to start dropping nuclear weapons on Ukraine and issue an immediate statement to the world that we will not, as Russia, tolerate an extension of this war. Ukraine must immediately accept surrender. Russia will not negotiate on this matter. And that prospect is terrifying, and it's maybe irrational, but it's very real. And this, by the way, isn't some far-fetched conspiracy. This exact scenario is what the Biden administration privately is scared of every time Ukraine requests longer range and more powerful weaponry. Because every time Ukraine makes serious strides towards offensively attacking Russia or seizing Crimea from Russia, the dominant fear within the Pentagon, within the Department of Defense, within the Central Intelligence Agency, within every research branch of Congress is, if Ukraine succeeds beyond our wildest imaginations, the resulting nuclear escalation from Russia may be worse than whatever we started with. What happens if nuclear weapons are deployed in Taiwan, in Korea, in Ukraine? You have four options to respond. from any of those countries' perspectives, as the United States, as South Korea, as any number of countries. The first option you have is nuclear counterforce. If, for example, Russia nukes Kyiv, the United States may say, this is an intolerable violation of nuclear deterrence. It is a gross violation of international law. We will attack every Russian submarine, every Russian missile silo, every Russian airbase, and destroy your country's arsenal. The second option is you might not use nuclear force. You might simply escalate conventional force. The United States might say, it is unbearable for Russia to utilize nuclear weapons against the people of Ukraine. We will put 100,000 Marines on the ground in Ukraine tomorrow. We will win this war for the Ukrainians, even if they were going to win it anyway. Third, you might pursue nuclear punishment, countervalue, if you will. The United States, or any number of nuclear powers, might say, we will begin nuclear strikes, not against just your nuclear facilities, but against your people, against your cities, against your leadership. Lastly, you might accept the ceasefire if Russia or North Korea says, we've had enough. We are not going to tolerate this. If the CCP says, we will not lose Taiwan, this is too essential to our national identity, we will do whatever it takes to be reunited with the people of Taiwan as a central element of the Chinese Communist Party, you might accept that ceasefire. None of these outcomes are good, but most people usually agree that 2 and 3 are probably the worst. Needless destruction of human life is gravely wrong under the best of circumstances and despicable under these. Countervalue is probably unthinkable. Conventional escalation is horrible, though, because every country in the world with some nuclear alliance or nuclear umbrella protection finds the prospect of non-nuclear response unthinkable. Imagine, for example, what Japan thinks if the United States responds to a North Korea nuclear attack by not signaling strong-willed retaliation. Japan's immediate thought is, if we face this same nuclear aggression from Pyongyang, the United States will not have our back. Nuclear counterforce and accepting the ceasefire are then the best options you have left. And these are very bad for very obvious reasons. There's no guarantee counterforce works, and there's a very real risk that you extend enormous amounts of nuclear suffering. Accepting the ceasefire is not great either, though. Sure, you might end the conflict, but the precedent that you set is terrible, not just in the immediate term, but also in the long term for any adversary hoping to blackmail any adversary of theirs into accepting a treaty they find unthinkable. Where does that leave us? Nuclear deterrence is a theory that everyone believes in. Everyone is told mutually assured destruction, mad this, mad that. But it's very unclear that mutually assured destruction works in the way people describe. And in a context where Russia is involved in an active military war against Ukraine, and Israel is involved in direct military hostilities with Hamas and potentially soon to be Hezbollah, and perhaps even Iran itself, the world faces a new range of deterrence threats that come from conventional wars escalating to the nuclear level. That could happen in Taiwan, it could happen in Korea, it could even happen to the United States. And that is where deterrence stands real risks. That leads nicely to the issue of nuclear proliferation. And why is that? Before we chat about nuclear proliferation, it's useful just to get some ground facts out of the way. There are 9 countries currently in possession of nuclear weapons. South Africa had nuclear weapons from around 1979 to 1989. They voluntarily and secretly disbanded their nuclear arsenal under the apartheid regime under the presidency of de Klerk. Ukraine, Belarus, and Kazakhstan were born nuclear, as the saying goes. They acquired remnants of the Soviet nuclear arsenal in the aftermath of the December 26, 1991 dissolution of the Soviet Union. They voluntarily handed over their nuclear weapons and disbanded them after the Budapest Memorandum, in which they agreed they would not continue to access those nuclear weapons in exchange for guarantees of security from abroad. So what countries do have nuclear weapons? The United States and Russia have by far the largest arsenals, followed by Britain, France, and China. It's worth noting that China currently has around 500 weapons and is planning to build up an arsenal to around 1,000. India, Pakistan, and Israel have arsenals of slightly unknown proportions, but believed to be somewhere between 80 to 170. North Korea has the world's currently smallest nuclear arsenal. When did countries get their nuclear weapons? The United States was the earliest in 45. Russia followed later in 49. Britain, France were the next two countries to come. They did receive security guarantees from the United States via NATO, but opted still to pursue their own independent nuclear weapons programs. China pursued nuclear weapons development throughout the late 50s and early 60s and conducted their first successful test in 64. India followed suit 10 years later by their own nuclear weapons test. Israel's nuclear weapons program is the only nuclear weapons program that's not publicly confirmed, although they absolutely have nuclear weapons and every now and then periodically make mistakes about acknowledging that. It's unknown exactly when Israel possessed nuclear weapons first. Most people believe it's 67. Pakistan first tested nuclear weapons in 1998, but likely possessed them well before that. North Korea's first nuclear weapons test came in 2006. Since then, they have steadily improved their long-range intercontinental ballistic missiles, such that the North Korean military now possesses the capability to deliver nuclear weapons against the United States. Of these 9 countries, 5 of them are signatories to the Non-Proliferation Treaty, which we'll chat about later, those being the US, Russia, Britain, France, and China. Incidentally, those countries are all also P5 countries. The remaining 4 have not signed the NPT. Noteworthy, North Korea was a signatory to the Non-Proliferation Treaty in the 1990s. They exercised their Article 10 rights to withdraw from the NPT just prior to developing nuclear weapons. Technically, North Korea's weapons program is not illegal under the NPT. It is, however, illegal under UN Security Council sanctions for North Korea's refusal to collaborate with International Atomic Energy Agency inspectors in the 90s and early 2000s. Now, it's just worth noting for a brief second before we start chatting about the implications of proliferation and how it relates to the deterrence debates we were just talking about. It is kind of crazy that just 9 countries in the world have nuclear weapons. Like, just pause for a moment and revel at how remarkable that is. There were people in the 1940s and 50s who predicted that within decades, 30 or 40 countries might have nuclear weapons, and only 9 do. And there's something truly remarkable about that. And it's worth noting that that matters a lot for debates around proliferation, because it's no longer viable to honestly claim that the entire world will go nuclear in the context of a military weapons program. That being said, there are still legitimate concerns about proliferation, and 2 of them are particularly salient. The first is the concern about horizontal proliferation, which is to say the concern that current states lacking nuclear weapons, called non-nuclear weapon states, often abbreviated as NNWS, may come into the possession of nuclear weapons. Iran is the big name in horizontal proliferation at the moment. South Korea may at some time also fall into that category. Vertical proliferation works in the opposing direction. Countries that currently have nuclear weapons, called nuclear weapon states or NWS, build up their nuclear arsenals, much as the US and Soviet Union did famously throughout the Cold War. Now, it's worth noting there is a third quote-unquote type of nuclear proliferation, but I'm not going to say it's the same thing because it is fundamentally quite distinct. And this is a way that countries acquire nuclear weapons that's rather unusual, which is the United States and Russia have practiced, both in the past and currently, forward deployments of nuclear weapons. What this means is the United States and Russia station nuclear weapons in other countries with those countries' permission, and to even give those countries some input in the event that those weapons were ever used over where they would be deployed. However, the United States and Russia retain launch authorization and launch control over those weapons. It is worth noting, on a related note, that people often misunderstand the nature of the Ukrainian, Kazakhstan, and Belarusian nuclear weapons programs that arose in the aftermath of 1991. The Soviet Union had a centralized launch doctrine, which meant that there were launch codes in Moscow that would be needed to operationalize nuclear weapons in Kazakhstan, Belarus, and Ukraine. Although those 3 countries all nominally had nuclear weapons, none of them had control over those nuclear weapons because Russia still had the launch codes for those nuclear weapons. A lot of people will often make a very poor argument that Ukraine generically had a fully functioning nuclear arsenal in 1991. No, They had nuclear weapons and maybe could have pursued strategies to turn that dis-operational arsenal into an operational arsenal that they could control. But the suggestion that Ukraine suddenly became a state with full autonomy over its nuclear arsenal is not particularly true. It's worth noting that the United States currently forward deploys nuclear weapons across predominantly Europe. Russia, as of late 2022, early 2023, I forget when, forward deployed nuclear weapons in Belarus. Of course, that does not mean Belarus gets to use those nuclear weapons at Lukashenko's discretion. That is still within the purview of the Kremlin and the military regime in Moscow. Key question: is nuclear proliferation good or bad? Short answer is that almost everyone agrees that nuclear proliferation is very bad. There are a small number of admittedly very smart people who make the argument that nuclear proliferation is good. They usually make a deterrence argument. This is, of course, quite reasonable. Most people, however, tend to agree that nuclear proliferation itself is not good, at least not in the horizontal context. There may be reasons to believe that new countries acquiring nuclear weapons may stabilize some conflicts, but given that the two countries that most people seriously think about acquiring nuclear weapons are Iran and South Korea, these are two contexts where nuclear proliferation almost certainly would not be good. It's difficult to see why a nuclearly armed Iran would make the world a safer place. Same too in the context of South Korea. Of course, Iran has a breakout period of well less than 2 weeks and is very close to successfully acquiring nuclear weapons. South Korea has merely flirted with the idea of a nuclear weapons program and has not even seriously considered beginning, just to make clear that those two are not both in the same boat. But here's an issue. When we say things like nuclear proliferation is bad or very bad, how bad is it? And here's why. If you think nuclear proliferation is like one of the worst things facing humanity, then you should probably be very hawkish in how you approach counterproliferation. So for example, every now and then, tournaments will set a motion that goes something like, this house believes that Israel should preventatively attack Iran's nuclear program. If you think nuclear weapons are just, or nuclear proliferation is just kind of like, not great, but not horrible, you probably should not support that motion. If you believe that a nuclear-armed Iran will fundamentally destabilize the Middle East in ways that risk millions of lives, you have a much easier time winning that motion as Gov. And in fact, that is Israel's doctrine. Israel has one of the world's most hardline stances on counterproliferation. It's called the Begin Doctrine. It was stated most formally in 1981. The Israeli prime minister made clear that the state of Israel will do whatever it takes to prevent Israel's adversaries from acquiring weapons of mass destruction. Of course, that also includes biological and chemical weapons. Nuclear weapons, of course, are also on that list. And that is why Israel is the country with perhaps the longest running history of offensive preventative military operations against nuclear proliferating allies. In 1981, Israel bombed Iraq's nuclear reactor at Ozark, which is not actually the region. It's like a combination of the region's name and the nuclear reactor provided to Iraq by France. In 2007, Israel famously bombed a suspected nuclear facility in Syria while collaborating with the United States. In 2010, Iran detected the presence of the Stuxnet computer worm and virus on Iranian centrifuges, which were probably, although not definitively, developed by Israeli cyber engineers in conjunction with the United States and the National Security Agency. And the Israeli Defense Force and the Mossad also has a very long history since the mid-2010s of assassinating at least now 4 known scientists working on the Iranian nuclear weapons program. So the point is, if you are really hawkish on proliferation, Israel's military doctrine should make perfect sense to you. If you are less hawkish or a little bit more dovish when it comes to matters of proliferation, you probably should find that policy a bit jarring. We'll attempt to answer the question of who's right and why in a bit. But before we actually address the is proliferation that dangerous, let's address the other part of the counterproliferation equation, which is, say you agree with Israel, or say that you more generally agree with the stance that nuclear proliferation is a dire threat we should do everything in our power to stop. exactly how do you stop other countries from acquiring nuclear weapons? There are two ways you can do it. You can focus on the demand side approach to proliferation, or you can focus on the supply side approach to proliferation. If you focus on the demand side, what you're trying to do is a country wants nuclear weapons for some reason or multiple reasons. If you can address those reasons in ways better than nuclear weapons would, then you can deter that country from acquiring nuclear weapons. The supply side approach is a bit more forceful. Countries might want to get nuclear weapons in ways that you cannot prevent. In other words, no matter what you offer to them, carrot or stick, they'll still pursue nuclear weapons. In that context, you might try to deny a country access to nuclear weapons. That's what Israel primarily does. The United States focuses predominantly on supply-side approaches to counterproliferation. So let's chat about the supply element of counterproliferation policy. The key idea when it comes to counterproliferation focusing on supply is to attack the development of nuclear weapons before countries actually have an operational nuclear bomb. And in order to do that, you can basically attack a country's nuclear weapons program at any point in its process from start to finish. But there are very broadly two broad components of any nuclear weapons program. First, countries must acquire fissile material. This goes way back to Section 1, so weapons-grade plutonium and uranium. And then they must assemble that fissile material into operational weapons and build delivery systems like bombs and intercontinental ballistic missiles and so on and so forth. A lot of people are intuitively confused by why you would try to degrade a country's access to fissile material. Presumably they could build fusion bombs. Remember, per that Teller-Ulam design, that fusion weapons combine both fission and fusion. So any country pursuing thermonuclear weapons must pursue the acquisition of weapons-grade fissile material. Now, in theory, if you wanted to deny countries access to these to nuclear weapons, you could attack either step. You could attempt to prohibit countries from acquiring fissile material. You could also attempt to prevent countries from building operational bombs. But doing the first is much easier than doing the second, because once a country actually has weapons-grade uranium or plutonium, it is very difficult to locate the facilities in which they are assembling weapons. And it is even harder to determine how you destroy those facilities. They're often buried deep underground. They're often located in regions you cannot easily hit without killing large numbers of civilians. And it's very difficult to properly understand where countries intend to assemble, to build, and to deploy their nuclear weapons. So if you want to stop a country from getting nuclear weapons by attacking the supply dimension of nuclear weapons, fissile material is the place to go. Now, it's worth asking the question, if you want to stop a country from getting fissile material, how do you as a country trying to get nuclear weapons get fissile material? And remember, there are two types of fissile material out there: uranium-235, plutonium-239. Plutonium does not occur naturally. You have to produce it chemically. And 99.3-ish% of all naturally occurring uranium is U-238, which is not fissile. And you need to refine uranium down to get that really nice U-235 isotope that is suitable for nuclear fission. How do you get U-235? You start by mining. So what you do is you go to one of the major uranium mines in the world. The majority of uranium is produced in just 3 countries: Kazakhstan, Canada, and Australia. You mine uranium ore. You usually extract it via a process called in situ leaching. You pump uranium ore to the surface. You then process that uranium ore into what's called uranium oxide. Usually takes the form of yellow cake, which is to say it's this kind of powdery yellow substance that's subsequently used in the enrichment process. Then you take that uranium yellow cake, and what you do is you convert it into a gas. You then put that gas into a centrifuge, which basically just spins the gas around at really huge speeds. And when the gas is spun at such vastly high speeds, there becomes over time slight differences between the slightly less heavy U-235 and slightly heavier U-238. And when the uranium is in the centrifuge, you start to separate out the lighter uranium masses from the heavier uranium masses. You feed the lighter uranium masses into the next centrifuge, and you do the same exact thing again. And basically, by the end of the process, at the end of all of this big old enrichment cascading rows of centrifuges, you end up getting a high quantity of uranium-235. You then take that heavily enriched uranium, which at this point probably contains well over 90% U-235, which is what is considered weapons-grade uranium. Just 5% is enough typically for conventional civilian power using nuclear energy. You take that high enriched uranium and you fabricate it, which is to say you process that enriched uranium gas into uranium dioxide, and then you turn that uranium dioxide into ceramic pellets. You seal the pellets in rods, and boom, there you go. There you have it. You have your weapons-grade uranium ready to go. How do you produce plutonium? Plutonium is a bit trickier because there is no plutonium in natural existence, so you must chemically produce it. And interestingly enough, the way that you produce plutonium is by fissioning uranium, because one of the many chemical products that comes from the bombarding of uranium with a neutron is plutonium. So what you do is you assemble a large amount of uranium into a nuclear reactor. You subject that uranium to nuclear fissioning. You then cool those uranium rods after they've undergone fissioning. Those uranium rods will contain trace amounts of plutonium. You can then extract that plutonium from those fissioned uranium rods using a whole range of complex chemical processes I'm not going to go into detail for. And at the end of that, you reprocess the plutonium using all of those kind of chemical features and chemical intermediaries. You then get independent, separate plutonium. You then fabricate that into ceramic pellets. You put that into rods, and boom, there you go. You have yourself weapons-grade plutonium. So just to be clear, uranium, to get it, you mill it, you mine it, you gasify it. Then you take your gaseous uranium, you centrifuge it, you convert it back into a solid, and you fabricate it into fuel. Low-enriched uranium can then be used to produce plutonium in a nuclear reactor. After you've put the uranium into the nuclear reactor, you cool and reprocess the uranium to separate out the plutonium. You then fabricate the plutonium into fusion fuel. Of course, remember, you can't produce plutonium without low-enriched uranium as an input. So here is the question we want to ask. If you are attempting to stop a country from acquiring nuclear weapons, the logical place to start is to attack and to degrade their access to weapons-grade fissile material, either U-235 or Pu-239. There are broadly 6 different places you could attack. You could attack the uranium mines and the milling facilities for uranium. You could attack the facilities that convert uranium to a gas and then enrich that gas in centrifuges. Or you could attack the final stage in uranium enrichment, which is the facilities responsible for turning enriched uranium into solid uranium fuel. You could, on the plutonium side of matters, attack the nuclear reactors in which uranium undergoes fission. You could attack the facilities where plutonium is chemically reprocessed, or you could attack the fabrication facilities. As it turns out, it's not a great idea to attack uranium mines or milling facilities because there are so many mines in existence and so many milling facilities that can be easily, quickly, and cheaply built that they're just too replaceable, and you don't get enough bang for your buck in targeting these as military facilities. The same is also true for fabrication facilities. Countries can easily conceal these facilities, and it's really hard to locate them because you're not quite sure what you're looking for. So if you're trying to deny a country like Iran access to nuclear weapons, it's very difficult to understand or identify where they're fabricating their plutonium or uranium. What about plutonium reprocessing facilities? Remember, that's where your plutonium is separated through chemical processes from your enriched uranium. Why shouldn't you just attack those facilities? The reason why is that these facilities are really risky to attack because they are packed full of a whole bunch of nasty chemicals that no one is really sure what would happen if you tried blowing them up, like with a bomb or a missile. So if you tried attacking, for example, an Iranian chemical reprocessing facility, which admittedly Iran likely is suspected of not having because Iran's nuclear program is suspected to predominantly be uranium as opposed to plutonium, which was outlawed under the JCPOA in 2015, which admittedly Iran has shirked since then. The point is, plutonium reprocessing facilities are a bad place to target because if the wind is blowing the wrong way, there's a good chance you condemn a lot of innocent people to death simply as a consequence of blowing up those facilities when those chemicals are released into the air or react with explosives. What about nuclear reactors? Here's the deal. Once nuclear reactors are in action, it is a horrible idea to try to destroy them or attack them as military targets, because what you end up getting is Fukushima. What you end up getting is the Chernobyl disaster. Not literally, in the sense that those were caused by external crises, one in the context of the tsunami, one in the context of natural man-made disaster, but rather in the context that destroying an operational, inactive duty nuclear reactor can do some really bad things when it comes to exposing local territory to tremendous and lethal amounts of radioactivity. So it's a bad idea to attack nuclear reactors once they are in action. However, if a country can identify where nuclear reactors are being built, attacking a nuclear reactor prior to its construction being completed is an excellent strategy, because the reactor has yet to begin fissioning uranium and hence poses no threat to the local population if it were destroyed, but is an easy sitting duck. The last and best place to target, and the place that is targeted by far the most empirically, especially by Israel and the United States, is the facilities responsible for gasifying uranium and then enriching uranium. These are, in other words, the facilities that use centrifuges to spin around uranium gas at extremely high speeds. And just empirically, by the way, this is where the vast majority of supply-side counterproliferation attacks come. The Stuxnet attacks targeted Iranian centrifuges. The 1981 and 2007 Israeli airstrikes against both Iraq and Syria targeted these types of facilities. Israel's attacks against Iranian nuclear scientists are principally focused on the enrichment side of the uranium problem. So this is where most countries focus their efforts. And the reason is quite simple. These facilities are very easy to find. And the reason they're very easy to find is because they are typically built with two interesting characteristics. Characteristic one, a country trying to pursue nuclear weapons development will not want to build a major conversion facility or a major set of centrifuges right next to a major civilian population. The risk of spying is too high. The risk of someone walking by in the wrong area is too high. The risk of local suspicion is too high. The risk of espionage is too high. It's not worth it. The better solution is that you build these facilities in the middle of literally nowhere. This is where China is currently building many of their nuclear weapons facilities. It's where Pakistan bases the vast bulk of its nuclear research facilities. It's where Israel stations its own nuclear weapons facilities. And sure enough, when you look at where Iran amasses its nuclear weapons programs and its development facilities, it is in the middle of deserts that are heavily underpopulated. Why does that matter? It matters because of characteristic two. These facilities are wickedly easy to identify when they're built in the middle of nowhere, even if they're built underground. And here's why. Because the facilities we're talking about are massive. For example, Iran is suspected of having well over 10,000 centrifuges in operation. 10,000. And these are not small machines, to be clear. They are large, large pieces of machinery. So these are large facilities in the middle of nowhere. Immediately, that's very easy to detect via radar. It's very quickly identifiable that there is something suspicious happening with these facilities. But increasingly, they are being built underground, so that's no longer viable. But there is a much easier way. This is the third characteristic of these sites that's useful to hit on. These sites in these facilities require an enormous amount of power. They require enormous amounts of electricity generation. Why does that matter? It matters because you cannot easily hide massive power surges to the middle of nowhere. And the way that countries keep a close eye on the suspected levels of uranium enrichment within Iran's nuclear program is by analyzing power flow to desert provinces in Iranian deserts where vast quantities of energy are used to power enrichment and conversion facilities. Remember, the Manhattan Project used 10% of all energy in the United States, the vast majority of it for the purpose of enriching uranium and acquiring weapons-grade plutonium. This is a process which is extremely energy and money and time intensive. And that makes these facilities easily identifiable and easily trackable because of their massive energy footprint. So that makes it easy to detect these facilities. But why would you as a military target them? It's because they're very high value, they're very expensive, and it takes a very long time to rebuild them. The machinery involved is extremely complicated, and often you need to get it from other countries. The personnel involved often have specialized knowledge of, for example, centrifuges and the way that you utilize gasification technologies to improve the efficiency of uranium enrichment. And the sheer bulk of just technology and energy production at these facilities, if destroyed, takes years for countries to recoup. So the point is, if there's a step in the process you want to attack, it is this step in the process. Of course, there are two reasons this is tricky. One, countries are perfectly allowed under international law to have enrichment facilities, as long as they are not enriching uranium to weapons grade levels. If a country is enriching uranium to 5 to maybe even 20% levels of U-235 concentration, perfectly allowable. So the problem is, in order to identify a country that is seriously pursuing weapons-grade uranium, you must not just identify the existence of uranium conversion and enrichment facilities, but also be damn convinced that those facilities are actually pursuing military-grade enrichment. The second complicating factor is that proliferators know that these are vulnerabilities, and they adapt preventative countermeasures, typically by relocating these facilities underground. So the major Iranian nuclear weapons facility looks like this by satellite imagery. It's at Natanz. It is the major program facility that Iran currently uses to enrich uranium. And it also has a secondary facility, but it is believed by most analysts to be less significant. This is a visual image as of 2021 by a nuclear weapons research institute that diagrams pretty nicely what this facility looks like. What you'll notice off the bat is how little there is visibly. I mean, you've got some mountains over here and you've got some buildings over here, but nothing like I was talking about. Vast, massive energy supply generators, vast cavernous halls containing rows upon rows of thousands of centrifuges. So where is this mythical nuclear program I'm speaking of? Almost certainly it's embedded deep within these mountains and within these tunnels. And the reason we suspect that, and by we, I mean like people who consider and think about the prospect of a nuclearly armed Iran, is that Iran has spent considerable amounts of time burrowing its nuclear weapons program underneath and constructing facilities underneath these mountains to sustain nuclear weapons programs. It's believed on top of that Iran has reinforced that with high-powered concrete that can stand up to 30,000 or even some people say 50,000 pounds per square inch of force, which is a staggeringly difficult barrier to overcome. And the other reason we know it is because above ground facilities have in the past actually been destroyed. There were a series of unconfirmed but likely Israeli attacks against this very military facility in July of 2020 at the very beginning of the pandemic. Since then, Iran has expedited its movement of nuclear weapons programs underground. That makes it difficult to pursue supply-side counterproliferation. That makes it plausible for us to ask the question, would it just be better if instead of denying countries access to nuclear weapons, we tried to understand their motives for getting nuclear weapons and address those interests? In order to answer this question, we need to ask a slightly different question, which is, why do countries want nuclear weapons in the first place? And this is, in my opinion, probably the domain where debaters spend the least amount of time in prep run rounds thinking seriously, because almost everyone just jumps to the same conclusion, which is countries get nuclear weapons when they face intense security threats. They want the deterrence benefits that come from mutually assured destruction, all of that. And there is historical evidence for this, obviously. The United States got nuclear weapons because it was terrified that Germany would get them first. The Soviet Union feared the US nuclear monopoly, so it developed nuclear weapons. Britain and France were afraid of the Soviet Union. China was afraid both of the United States and to some extent the Soviet Union. India was afraid of a nuclearly armed China. Pakistan was afraid of a nuclearly armed India. Israel was fearful of its many allies in the region, some of which may have considered at some point pursuing nuclear weapons. North Korea is existentially terrified of what the ROK in the US means for its security. So we might look at all of this and say, aha, countries get nuclear weapons because they're afraid for their security. But is that right? There are problems with this argument. And the by far most important question to ask is not really a scientific or logical or structural or debatey question. It's just a human question. If countries get nuclear weapons because they're scared of war, to put it crudely, why on earth do just 9 countries have nuclear weapons? I mean, the world without nuclear weapons remains mired in conflict, and brutal, harrowing conflict at that. It's not like these are the only 9 countries, or 10 if you include South Africa, to have ever thought, gee, wouldn't it be great to get nuclear weapons? That can't seem to be it. Maybe your response to this is, okay, sure, but look, developing nuclear weapons is hard. We just saw that. It's hard to enrich uranium and all of that. And clearly not all countries in the world have the technological know-how or capability to do this. Maybe, but just 9? There are some powerful, technologically advanced countries in existence that never got nuclear weapons. And the Cold War in particular underscores this point. Why, for example, didn't West Germany get nuclear weapons? Sure, it's a part of NATO, but it faced very much military threats both from East Germany and the Soviet Union. Why didn't Taiwan get nuclear weapons? I mean, after, for example, the United States shifted its support to the PRC as opposed to the ROC, why wouldn't Taiwan fear existentially that it needed its own nuclear deterrent? Why didn't South Korea ever get nuclear weapons? Why doesn't South Korea get nuclear weapons today? And on top of all of this, isn't it weird to make an argument that says countries get nuclear weapons because they're afraid for their security, and then justify it by retrospectively looking back at every country that got nuclear weapons and superimposing upon those countries the security problem that may have potentially motivated their nuclear programs without actually being sure that's why they got nuclear weapons? The point is not security concerns are irrelevant. The point is that there are reasons to believe this is not the only reason countries care about nuclear weapons, and there must be other factors at play. For example, Britain and France had no explicit security need for nuclear weapons. They were protected by Article 5 of NATO by the time they acquired nuclear weapons, but they got nuclear weapons anyway. South Africa chose, without international pressure, mind you, to give up its nuclear weapons in 1989. The world didn't know of its nuclear weapons at that point in time. Sure, there were protests against apartheid and the evil it inflicted on Black South Africans, but at that moment in time, the South African decision to give up nuclear weapons was not one driven, at least in theory, by security. After all, acquiring weapons, that makes sense from a security perspective. Giving them up is harder to explain. Taiwan, South Korea, Germany, any number of countries probably should have considered getting nuclear weapons, but they never did. And India is an interesting example. Most scholars believe that after China's first successful missile test in 1964, India probably could have developed a functional nuclear weapon within 3 to 5 years, probably 1967 to 1969. And India, to be clear, had good reason after prior conflicts with China to fear what China might do with its nuclear weapons against the Indian state. But India didn't accelerate its weapons program. India didn't test its first nuclear weapons until 1974, a full decade after China. If India was concerned first and foremost with security, it seems awfully hard to explain that outcome. The point is, the national security model of proliferation is deeply incomplete, and there are other demand-side factors at play. And there are at least 3 that are worth talking about. One is the strategic security understanding of how interactions between allies, proliferators, and adversaries influences the relative value of proliferation. The second is to look at the domestic interests behind nuclear weapons, and the last is to talk about prestige. So let's first chat about the game theory behind nuclear proliferation. And the core concept to take away here is countries do not decide to develop nuclear weapons based solely on their own interests. They also have to factor in 2 other types of actors, those of their adversaries and those of their strong or nuclearly armed allies. Why? Because both of these actors have huge incentives to oppose nuclearization in different ways. Adversaries have a very obvious reason why they do not want to see you develop nuclear weapons. They will suffer from a reduced security balance if you develop nuclear weapons. So, for example, Why did South Korea oppose North Korea's development of nuclear weapons? Because South Korea's security is deteriorated by North Korea's nuclear arsenal. Why did India oppose Pakistan's development of nuclear weapons? Because India's advantage over Pakistan was undermined by the Pakistani nuclear weapons program. Why does Israel oppose Iran's nuclear weapons program? Because it undermines Israel's regional strategic security. So adversaries have a huge incentive to stop you from getting nuclear weapons. And we just saw how they would do that. They would do it through supply-side counterproliferation. What does supply-side counterproliferation entail? It entails military conflict. It entails bombing your enrichment facilities, invading your gasification facilities. It involves military action, boots on the ground, military force. That is how adversaries stop you from getting nuclear weapons. That is how Israel stopped Iraq from getting nuclear weapons in 1981. It's how it stopped Syria from pursuing nuclear weapons in 2007. It's how Israel has prevented, thus far, Iran from acquiring nuclear weapons in the last 15 years. But there's another interesting issue at play here. Allies also have huge incentives to oppose and to stop you from getting nuclear weapons. Now, there are two reasons for this, one of them more cynical than the other. The less cynical reason is, if you're the United States, why would you not want South Korea to develop nuclear weapons? Well, presumably part of it is because this would destabilize the region. There's a risk of an arms race. Other countries may question your security guarantees and so forth. But there's a more honest and cynical reason why allies do not want you to ever consider nuclear weapons. And this is the reason, by the way, the United States does not like its allies nuclearizing. If South Korea got nuclear weapons, its dependence on the United States for security and defense drops precipitously, because North Korea now has the most powerful, potent instrument of defense and deterrence ever developed. The United States enjoys, crudely, the fact that South Korea must rely on the United States for its security. And that means that South Korean foreign policy is handicapped in some sense by the constraints imposed upon it by Washington. The United States will always have maximal influence over South Korea's international strategic positioning, because South Korea, at the end of the day, can never take any action that seriously risks angering the United States enough that the United States would consider downgrading the strength of its security ties with Seoul. And for that reason, the United States would stiffly oppose a South Korean nuclear weapons program, because it would reduce the degree of leverage the United States has over South Korea. But here's the issue. You're a country, you want to nuclearize. Your adversaries don't want you to nuclearize. And they have a clear way that they might stop you from nuclearizing. They will go to war. Your allies also don't want you to nuclearize. How would they stop you from nuclearizing? They could do one of two things. They could offer you something for not nuclearizing. They could, for example, say, we will guarantee you protection so long as you do not develop nuclear weapons. Or second, they could go the stick route. They could threaten punishment in the form of unilateral military withdrawal. If you develop nuclear weapons, we will not provide you with security anymore. And that is crucial. Allies can choose to protect proliferators, or they can choose to withdraw. But there's another and more important way that allies shift the balance here. Adversaries and allies both oppose nuclearization. But remember, developing nuclear weapons is a process, and the process of developing nuclear weapons takes time. And the time between starting nuclear weapons development and finishing nuclear weapons development is a time where you don't yet have the deterring power of nuclear weapons because they're not yet built, but you are at huge risk of preventative war by your adversary. What allies can do is implicitly protect their proliferatory allies from an adversary's preventative attack. For example, if South Korea could somehow convince the United States that it was in US interests for South Korea to develop a nuclear arsenal, the United States might say it will protect South Korea against a preventative North Korean attack against South Korean nuclear weapons facilities. That would greatly thwart an adversary's ability to disrupt nuclear weapons development. So let's put that theory to the test. Strategic interactions between allies and adversaries and proliferators influence the probability that countries will acquire nuclear weapons. And let's go to the core example we've harped on now quite for a bit, which is, why didn't West Germany, Taiwan, or South Korea develop nuclear weapons? They all faced intense security threats, either from the East Germans, the Chinese, or the North Koreans. And they all, as a matter of fact, did want to pursue nuclear weapons development. Why didn't they? It's because the United States refused. The United States in the 1970s and 80s was very clear to West Germany, to Taiwan, and to South Korea, when those three countries all independently considered developing their own nuclear arsenals. The United States threatened West Germany, threatened Taiwan, threatened South Korea, that the United States would unilaterally withdraw military support for those regimes if it went through on their threats to develop nuclear weapons. And if those countries did not develop nuclear weapons, the United States would reward them with military protection. That is why the United States, at least until it switched over to recognizing the PRC, the United States provided extensive military ties, extensive support to Taiwan, and arguably why, to some extent, even to this day, the United States, despite its official lack of recognition of Taiwan, continues providing extensive military relief to the Taiwanese under the 1979 Taiwan Relations Act. It's also why the United States maintains such a massive military presence in South Korea. It's also why Germany is one of the strongest US military allies in NATO. It is because the United States made a promise to these countries that you ought not proliferate, and if you do, you will be punished, and if you do not, you will be rewarded. Here's a different and a trickier example. Why did Iraq's nuclear weapons program fail? Because it failed many times over. It failed in 1981. That's when Israel bombed its nuclear reactor. It failed again in 1991 in the first Gulf War, when the United States obliterated and crushed what then was a nascent nuclear weapons program in development by Saddam Hussein. It was crushed again in 1998 in yet another conflict with the West. And of course, 2003, the United States manufactured a bullshit excuse to invade Iraq. Of course, Iraq did not possess nuclear programs to develop nuclear weapons of mass destruction or nuclear weapons. But of course, had Saddam Hussein pursued nuclear weapons, then they would have been crushed again. That leaves us asking an interesting question. Why did Iraq fail? It failed because in the strategic interactions between its non-existent powerful nuclear ally and a powerful adversary in the form of the United States working in collaboration with Israel, Iraq had the interest in nuclearizing, but lacked the ability to nuclearize. And that is why Iraq attempted to develop nuclear weapons, because it faced an existential security threat in the form of Israel, but its nuclear weapons program failed because it lacked the security for its weapons program to be complete. Why did Pakistan's nuclear arsenal come to fruition by contrast? It also had a powerful adversary, a more powerful adversary, in fact, than Pakistan, in the form of India. But it also, in the aftermath of the Soviet invasion of Afghanistan in 1979, had a powerful ally in the form of the United States, which agreed to turn a blind eye to Pakistan's nuclear weapons program so long as the United States could maintain military bases in the country and utilize Pakistani services for the purposes of collecting information on Soviet forces in neighboring Afghanistan. That is why Pakistan believed it could nuclearize in the 1980s, and that is why after the 1981 decision by the United States to upgrade defense ties with Pakistan, the Pakistanis were able to develop a successful nuclear weapons program without significant interference from the Indian armed forces. Pakistan was able to nuclearize, Iraq wasn't, and strategic interactions between allies and adversaries are a crucial reason why. There are two other reasons that we should consider for why countries develop nuclear weapons. One of them is non-security-based domestic considerations. For example, it is unclear whether this is true, but there are some scholars who say part of the reason India developed nuclear weapons is that by the early 1970s, in the midst of a mass economic slowdown and widespread unpopularity with the Congress government, there were substantial incentives domestically for Indira Gandhi to consider the development of nuclear weapons for the sole reason that they would boost the domestic popularity of her administration. That alone is probably not the reason India decided to develop nuclear weapons. However, it is certainly true that the popularity of the Indian government rose significantly after news of the Indian nuclear test broke. And it's also true that domestic actors within the Indian bureaucracy played a substantial role in advocacy for nuclear weapons, despite there being, at the time, little security-based dimension to their advocacy. But there are also other reasons to believe domestic actors can influence nuclear weapons policy. Famously, the Soviet Union, in retrospect, developed much of its nuclear weapons not for objective security reasons, interestingly, but rather because the domestic bureaucratic committee with oversight of the Soviet nuclear arsenal continually demanded more and more funding to satisfy the selfish interests of those bureaucrats, which in turn led to the expansion of the Soviet nuclear arsenal. So in many instances, domestic considerations are substantial in influencing countries' decisions to nuclearize. Norms and prestige also matter too, especially to bureaucratic interests domestically. Why did France, for example, develop nuclear weapons? Charles de Gaulle was actually quite explicit about this. Security was only part of the equation. The other issue France cared about, France could not credibly claim to be an international power in the absence of a French nuclear arsenal. At that moment in time, possessing nuclear weapons was the determining indicator that a country was truly powerful. And that was what France desired when it pursued nuclear weapons development. And just in the same way, for example, as many countries run extraordinarily losing airlines, the reason they do so is not per se because it's profitable or even because it objectively is good for their country. It's because bureaucratic actors view that type of thing as good for their image and international reputation. And for very many decades, until the taboo against nuclear weapons became particularly fierce and the counterproliferation movement grew particularly strong alongside the Global Zero movement, that norm suggested that nuclear weapons were indeed prestigious. So, there are two ways you stop countries from getting nuclear weapons. You stymie access to supply, or you provide alternative carrots to satiate countries' demand for nuclear weapons. That is why not all countries in the world have nuclear weapons, and why just 9, at most a total of 10 historically, have ever developed their own nuclear weapons programs. Because the interests governing nuclear weapons development are more complicated than just security. And it's also worth noting that different countries have different interests. The Soviet Union was motivated by security, France probably by international standing, Israel by security, Pakistan probably to some extent by international standing, probably to some extent by security, North Korea probably some extent to security, some extent to domestic considerations. The point is, proliferation is dangerous. The way that you limit proliferation is either through military actions to halt the supply or diplomatic actions to halt the demand. A brief note, the JCPOA, the Joint Comprehensive Plan of Action, was the 2015 deal struck between the P5+1 countries and Iran, which offered tremendous sanctions relief to Iran in exchange for Iran putting domestic handicaps on its nuclear weapons program, but not entirely eliminating its uranium enrichment facilities. Trump withdrew from that agreement several years later into his administration. He imposed secondary sanctions on Iran, prohibiting the European Union, which remained in the JCPOA, from trading with Iran. Iran has since then substantially infringed upon the terms of the JCPOA, which it has no incentive to comply with. Subsequently, its breakout period is now believed to be less than 2 weeks. That means if Iran seriously harbored intention to develop an operational nuclear weapon, it could have one in 2 weeks. The question that Israel now must face, and has faced for the last 2, probably 3 years, is what must Israel do in face of a 2-week away from nuclearly armed Iran? And the answer is, it depends mostly on how you answer a different question. The question that you need to ask is, should we be existentially terrified of a nuclearly armed Iran, or should we only be moderately concerned?
We're going to now walk through the reasons proliferation is bad. We've thus far talked about how you stop proliferation, and we've talked about the logic behind proliferation. But we also mentioned that proliferation is bad without explaining why. So let's now explain why proliferation is a force of destruction. There are 7 ways it is. First, there is a real risk that nuclear weapons are used directly. And there is lots of reasons off the bat to believe this argument shouldn't be too worried about. In other words, we shouldn't be terrified that any country would ever use nuclear weapons. For starters, deterrence works. We've had nuclear weapons since July 45. They've been used twice, and that was at the end of World War II. Never again have they been used in direct conflict. The nuclear taboo is a powerful force. Countries are routinely unwilling to even float the idea of using nuclear weapons. Sure, NATO considered it, as do some countries like Russia, but if a military general was actually asked to put those plans into operation, good chance there's some pushback. And for that matter, leaders have huge disincentives to use nuclear weapons. Unless you are literally insane as a leader, you can be a mass murderer and still not use nuclear weapons. A common argument you'll hear people make against nuclear proliferation is, look, it's really bad for the bad guys to get the bomb. But there's a problem there. The bad guys have had the bomb before. 2 of the 3 greatest mass murderers of the 20th century were Joseph Stalin and Mao Zedong, both of whom possessed nuclear weapons, and neither used them. This is not to say, aha, all bad leaders must therefore not pose a nuclear threat. That would be bizarre. The point is just to say, look, it's not the case that evil person with nuclear weapon equals nuclear apocalypse. We've had this before and have it right now with Kim Jong-un, arguably even for that matter Vladimir Putin, and the world has not yet been destroyed. At the same time, you might be concerned about the use of nuclear weapons. One of them is just accidental use of nuclear weapons. The world has consistently and routinely found itself on the brink of existential apocalypse. The Cuban Missile Crisis brought us within mere inches of destruction. On numerous occasions, countries have seriously thought that their existence was put on the line. The risk of accidental catastrophe is terrifying. But there are also other reasons to believe nuclear weapons might be used that don't have to just rely on random happenstance. Leaders might be irrational. They might act in ways that we deem not plausible. Extended deterrence is difficult as well. What's to stop a nuclear weapon state from nuking a non-nuclear weapon state? And all of the arguments we've outlined about how deterrence fails are reasons to believe that nuclear weapons may very well be used. One of the most powerful reasons to believe nuclear weapons might be used is that countries may experience what's called a use it or lose it fear. Imagine that you're a country with nuclear weapons in the midst of a conventional war, and you're worried that the other country is trying to use conventional weapons to degrade your nuclear arsenal. For example, China rather famously uses the same missile launchers to launch conventional missiles as it would use to launch ballistic missiles, which carry nuclear warheads. If China is afraid that the United States or Russia or any number of countries potentially involved in a military dispute with China on a large scale was destroying Chinese missile launchers, might China be afraid that it was losing its ability to use nuclear weapons and deploy nuclear weapons preemptively before it had lost full control over its nuclear arsenal? All of this is to say, look, nuclear weapons are huge risks. And every new country to develop nuclear weapons very well may end up using them in a way that causes enormous amounts of destruction and a very real risk of a chain reaction of retaliation that ends the world. That's the famous ending scene from Oppenheimer, if you've seen it. The second argument people tend to make against nuclear weapons and proliferation is nuclear terrorism. Candidly, I think this is a very bad argument, and I think we can all sleep sound at night without deep fear of nuclear terrorism for 2 reasons. One, there is no historical evidence that countries have even entertained the prospect of nuclear terrorism. See, countries have considered prospects of using nuclear weapons, they've strategized for it, they've planned for it, and all of that. There is no evidence that any country has thus far seriously planned, let alone considered, handing nuclear weapons to terrorists. But of course, it's the age of structural reasons and debate, and maybe you don't find that persuasive. So here's the structural logic as well. The actual logic behind nuclear terrorism is terribly bad. And here's why. When people say a state might give terrorists nuclear weapons, what they're often really making is an argument about direct use. Because the logic they usually give is like, countries would give nuclear weapons to terrorists because they want terrorists to harm their enemies and do terrible bad. And that's totally fair, but that's not really an argument anymore about nuclear terrorism. It's an argument that a country will use nuclear weapons and they will just give their nuclear weapons to a terrorist group to do the bidding for them. So the real argument that people tend to make about nuclear terrorism has an implicit clause that people usually leave unstated. Countries, all else equal, would much rather do nuclear attacks themselves than hand a weapon off to a terrorist group. Simplest reason, terrorists are notoriously unreliable, and you have no guarantee that when you give a nuclear bomb to a terrorist, they will use it quite in the way that you told them to. And that's a terrifying prospect, even for a deeply evil and deeply messed up regime. So the point is, nuclear terrorism is pretty specific. Nuclear terrorism would occur in one very specific context. It would occur in a context where a state wants to deploy nuclear weapons, but doesn't want to deploy nuclear weapons itself. Why would a state want to deploy nuclear weapons, but not deploy nuclear weapons itself? There's really only one reason. A country wants to inflict nuclear hellfire on its adversary, but does not want to face retaliation. And a country might believe that it can get away with a nuclear attack by giving a weapon to a terrorist group such that the attack cannot be traced back to it. A common objection here that people say is wait a second, how could countries ever be held accountable for a nuclear attack of their own doing? For example, if a country fires a rocket, clearly we have no clue where it came from. Unfortunately, this is not true, or fortunately, depending on your perspective. Every rocket of any considerable distance or range from every nuclear weapon state in the world is well known and well understood to the international community. The reason that matters is that every rocket used by countries has identifiable heat plumes. So once a rocket is launched, or once an ICBM is launched, or once a bomb is dropped from a particular bomber, it's very easy to identify via sensing technologies what rocket or what type of bomb was used, and then trace it back to the country in question. So the only reason a country might use nuclear terrorists as their vehicle for destruction is because they think that the terrorists will obscure the state's role in the terror attack, and therefore they will not be held accountable and will not face nuclear retaliation. Here's the problem. If a country was going to give nuclear weapons to a terrorist group, it would only ever possibly give nuclear weapons to a terrorist group it had established connections with. Simplest reason, you need to work with a really good terrorist group to get a terrorist attack off on a nuclear scale. People underestimate how difficult it is to do high-level, sophisticated terrorist attacks. This requires training, preparation, a whole range of mess involving international travel. This stuff is complicated. And there's a bigger problem. A state giving nuclear weapons to terrorists would need to give weapons to a terrorist group it trusts, it has connections with. Because you need to make sure that if you're giving a weapon to a terrorist group, that group is not already monitored or infiltrated by, say, a Western intelligence agency. Why does that matter? There's a trust anonymity paradox at play. If a state is considering arming terrorists, its motive is to remain anonymous. But that state would only give weapons to a terrorist group which is well established and hence has the capability to execute a nuclear terrorist attack, and is a terrorist group with which the state has extensive pre-existing ties. The problem then is in the immediate aftermath of a nuclear terrorist attack, billions of dollars and thousands of personnel around the world will be mobilized to determine the perpetrator of the attack. And almost beyond a doubt, the perpetrator will be discovered. If nothing else, lots of terrorists claim responsibility for their attacks. Why does that matter? If an attack is very rapidly attributed to its terrorist attack, or to its terrorist perpetrator, the state sponsor behind that terror group is very quickly, easily able to be found out. And very rapidly, within probably 8 hours after the attack, you, the state sponsor of a nuclear terrorist attack, have been identified and you will face retaliation. Now, there's two questions that you're probably asking yourself here. Question number one, this is all speculative. Sure, this logic makes sense, but it's not 100% guaranteed to be true. And that's true, that's 100%. But here's the problem, right? The problem is the type of country that would give nuclear weapons to a terrorist group is evidently scared. They're scared of nuclear retaliation. That's why they're not doing nuclear weapons attacks directly themselves. But if the state is that scared, like, the probability they're going to face retaliation is way too high to satisfy that state, which is evidently quite scared of retaliation. So the point is, the type of state considering nuclear terrorism is sufficiently risk averse that they wouldn't directly launch a terrorist attack. If they are that risk averse, then the probability of retaliation is still way too high if you gave nuclear weapons to a terrorist group under any context. And that's why nuclear terrorism just seems extremely implausible, because they're not going to reap the benefits of anonymity. They are going to provide weapons to terrorist groups they are well connected with. That terror group will be found out. The moment that that terror group is found out, its connections to its state sponsor are quickly identified. And there's a final reason to believe that this whole nuclear terrorist argument doesn't work. Imagine for a moment, hypothetically, a terrorist group detonated a nuclear warhead inside Manhattan. Millions would die. In the immediate aftermath of that attack, the United States and the way it would respond would not be like a judge and a jury attempting to prove guilt beyond a reasonable doubt. The United States may very well come out of a nuclear terrorist attack against Manhattan saying, the age of rogue states possessing nuclear weapons will come to an end. In 48 hours, every single nuclear weapon facility in Pakistan will be leveled, in Russia will be leveled, in North Korea will be leveled. We will eviscerate whatever Iran is building up. It is, in other words, entirely plausible that in the aftermath of a nuclear terrorist attack, the type of response you would get from the victimized country would be so crazed and anger-driven that many countries would immediately be blamed. Remember, there are 9 nuclear weapon states in existence. Of them, some are unbelievably unlikely candidates for nuclear terrorism. Britain and France come to the top of the list. Sure, they have evil histories of colonialism, but are much more likely to simply carry out operations directly than use nuclear terrorism. At that point, you're left with a smaller number of countries, and the most likely countries to use nuclear terrorists, probably either the ISI within Pakistan, which has extensive and pre-existing and well-established and well-documented ties to terrorist groups focused against India, or North Korea. In other words, you are starting the search for nuclear terrorists' state sponsor with a list of 2, maybe 3 if you include Russia. That makes it very easy to identify who is responsible for these attacks. Anonymity is the foundation of nuclear terrorism. Nuclear terrorism will never be anonymous. Hence, nuclear terrorism is not probably a large threat. The third reason to fear proliferation is loose nukes. In my opinion, this is probably the biggest fear, and it goes something like this. Nuclear weapons can be stolen, especially if non-state actors could overpower the security personnel at nuclear facilities and steal operational nuclear weapons. The bigger fear, though, is regime collapse. In December of 1991, the Soviet Union collapsed, and there was extreme fear within the Pentagon and within MI6 and within the Mossad and within every intelligence agency in the world, including in Russia, that the collapse of the Russian state and the profound socio-political instability that followed would risk nuclear weapons falling into the wrong hands, being sold on black markets, being stolen by terrorists, being seized by Chechen separatists. And this fear was so intense that the United States, and this is crazy, passed a law in the 1990s authorizing US taxpayer dollars to help secure Russian nuclear weapons. Just to be clear, the United States passed a law in the 1990s, a spending bill that is, that gave US money to protect Russian nukes. That's insane. But that's the fear of loose nukes for you. It is very worrying that in the aftermath of a regime's collapse, the security situation may deteriorate to the point that nuclear weapons facilities cannot pay for security personnel. And all of a sudden, you may very well have missiles, bombs, warheads, re-entry vehicles sitting like easily stolen ducks for any terrorist to swoop by and steal. Now, how scared should we be about this? The short answer is somewhat. If you look at a regime like, for example, North Korea or Russia, and according to some analysts, maybe even potentially Pakistan, these regimes may not last forever. Take, for example, the June 2023 Wagner Group mutiny against Putin led by Prigozhin. That is a very clear indication that his regime seems to not have long-term survivability. If those countries, if any one of them collapse, there's a real risk of weapons falling into the wrong hands. And that's where the nuclear terrorism argument becomes real. That is where a nuclear terrorist group becomes plausible. And by the way, it's not just those countries. Look around the world. Israel's at war with Hamas. There's a good chance the war potentially could metastasize. Perhaps other groups, other states enter into the mix. The United States maybe isn't that close to a civil war, but certainly isn't looking great when it comes to matters of polarization. Pakistan has been roiled with protests and instability. Just consider the controversy around Imran Khan, their most recent prime minister, ousted from power by the military. China and the CCP has long staked its legitimacy on economic growth domestically, but is now hitting the middle income trap and facing a looming economic disaster. There are many nuclear powers in the world that arguably are at very real risk of regime collapse. Maybe not now, maybe not in 5 years, but certainly in the next 50, and that's worrying. At the same time, we might not be that concerned about loose nukes. For one thing, theft is not particularly worrisome. Nuclear weapon facilities are guarded heavily. These weapons are usually not easily deployed or detonated, even if they fell into the wrong hands. And most states recognize that there are dangers of theft and they take precautions. Regime collapse as well has some safeguards in place. The unfortunate and sad reality is that oppressive regimes don't fall often, at least not in the 21st century. People have claimed that North Korea will collapse and have claimed this since the 1960s, and it hasn't happened yet. And it's not obviously clear that military coups are that big of a threat. Most militaries divide authority, for example, between Artesh and the Iranian Revolutionary Guard Corps in Iran to ensure that no one faction of the military has an easy time assuming power. That doesn't defeat the loose nukes argument, but at least suggests it's not that worrisome. The fourth concern around proliferation is essentially the arms race concern. Once one country gets nuclear weapons, other countries must as well. As we've seen, though, this is not a concern we need to take all that seriously. One country's acquisition of nuclear weapons rarely has led to a full-blown regional arms race, and it's the reason why many countries, as a matter of fact, do not have nuclear weapons that maybe arguably should. The fifth and much better argument for against nuclear weapon proliferation is called shield for aggression. And the logic goes something like this. Nuclear deterrence is too good at what it does. Nuclear weapons are so powerful as deterrent forces that they give countries the comfort and stability to believe they can act aggressively in conventional ways and never face aggressive responses in retaliation for what they do. Maybe Putin would have thought more carefully about invading Ukraine last year if he feared that he would be met with fierce military retaliation from the West. But he knew he never would because he was backed by his nuclear umbrella. His aggression was shielded by a nuclear force. Maybe North Korea wouldn't be as aggressive and as hostile and as belligerent as it is if it didn't have the comfort and stability of its nuclear warheads. Maybe China might behave differently around countries like Vietnam or the Philippines if it didn't have the comfort of its nuclear arsenal. Maybe the same thing is true of Pakistan. This is the shield for aggression. But curiously, there's very little empirical evidence to support the shield for aggression hypothesis. This is a very crude graph, but it actually shows a very important conclusion. Countries don't seem to engage in more conventional, low-level disputes after coming into possession of nuclear weapons. Now, obviously, yes, causation, correlation, all of that. But it's just to say, if the shield for aggression argument was true, we would expect that countries would become substantially more aggressive after acquiring nuclear weapons. Empirically, they don't. And many of the concerns I just outlined, honestly, they're not that persuasive. North Korea has a long history of aggression well before 2006. The Chinese government has a history of being militarily belligerent even prior to 1964. Pakistan's funding of anti-Indian terror groups traces its history well prior to the 1998 first Pakistani nuclear test. It's not obviously clear that there is empirical backing for this argument. The sixth concern about nuclear proliferation refers to the erosion of the Non-Proliferation Treaty. And in order to understand this argument, we'll need to go into a bit of background as to what the NPT is. The NPT is formally called the Treaty on the Non-Proliferation of Nuclear Weapons, usually dubbed the NPT. It was formed back decades ago, well prior to the collapse of the Soviet Union, and it imposes three types of obligations upon nuclear weapon states and non-nuclear weapon states. One is non-proliferation. Countries agree to not spread nuclear weapons or to acquire them without authorization. Second, the NPT demands that peaceful applications of nuclear technology, like, for example, civilian energy produced by civilian nuclear reactors, must be shared by nuclear weapon states with non-nuclear weapon states at reasonable cost. Third is disarmament. The nuclear weapon states of the NPT agree under the NPT to, and I'm quoting directly here, move in good faith towards cessation of arms races and eventual nuclear disarmament. Problem: there is no binding temporal commitment for when this must happen. Now, there are lots of criticisms of the NPT, and the four most common ones go like this. One, the NPT is hypocritical. It divides the world into two categories, those with have nuclear weapons and those which do not have nuclear weapons, and ossifies and calcifies a two-stage nuclear order in which some countries are allowed access to the most powerful instruments of war and statecraft ever, and others are perpetually denied them. Second, people criticize the NPT for essentially lacking enforcement mechanisms when it comes to disarmament, and that's pretty much true. Third, lots of countries, or at least to be clear, Iran and North Korea, accuse the IAEA, the International Atomic Energy Agency, of being nothing more than a spy agency. The additional protocol, which essentially gives the IAEA nearly unlimited authority to inspect suspected nuclear weapons development sites, has essentially confirmed lots of those countries' worries. And lastly, nuclear weapon states often are outraged by the ability to withdraw from the NPT and the simultaneous obligation of nuclear weapon states to provide peaceful nuclear technologies to non-nuclear weapon states. A lot of nuclear weapon states make an argument that goes something like this. The NPT requires us to give you peaceful nuclear reactors, to give you centrifuges, to give you the technology that you need to build peaceful nuclear technologies. Problem: those technologies can also be harnessed for military purposes. What is to stop you from gaining technology and gaining know-how and then withdrawing from the treaty and building the very bombs that this treaty was meant to prevent? But criticism aside, the NPT does a lot of good in the world. And the main good that the NPT does is it reduces countries' individual incentive to pursue militarization or nuclearization, because it gives some confidence that other countries won't do that because they're in the NPT. And the NPT is a powerful instrument of non-proliferation. But the problem is that the NPT is, at the end of the day, just words on a page. And those words on a page matter only if they are credible words on a page. The issue is this. What happens every time a new country gets nuclear weapons is it undermines the credibility of the NPT, especially when it's not a country like North Korea or Iran, but a relatively established democratic state like Japan or South Korea. That is concerning because it throws the credibility of the NPT into question and very much may encourage other countries to reevaluate their own non-proliferation doctrines. The last concern around proliferation is one we've already touched on. It's essentially the nuclear blackmail or atomic queen argument we outlined earlier. The argument goes something like this: weak autocratic states are able to blackmail their way to victory against more powerful conventional forces through threats of nuclear warfare, even if those threats never come to fruition. The United States makes a similar-ish claim. If you are more sympathetic to this claim, then this might strike you as persuasive. If not, it will not. The US argument says the rules-based order is fundamentally incompatible with nuclear proliferation, both because illiberal actors are difficult to rein in once they come into possession of nuclear weapons, cf. North Korea, and because liberal states which come into possession of nuclear weapons require a reduced level of multilateral support from countries like the United States, hence undermining norms of cooperation and security harmonization. So where does that leave us? Proliferation is bad, but it's not clear exactly how bad proliferation is. And the reason is proliferation raises many risks, but we don't really know how probable those risks are of manifesting in real intangible harm. And we can never perfectly envision a counterfactual world which does not have nuclear weapons. A quick note, though. Oftentimes when we debate about the benefits or risks of proliferation, these arguments are made in generalities. The good news is we know exactly who has nuclear weapons and exactly who's considering nuclear weapons. You can always make arguments about proliferation and its potential benefits or costs with high degrees of specificity about the countries involved, their specific interests, and the adversaries they are involved with. So, that concludes our discussion of deterrence. The last thing then that we'll discuss is missile defense and how it relates to technological advances in military technology around nuclear weapons. And this at first seems a bit like a logical leap to go from a discussion of proliferation to missile defense, but you'll see the connection in a moment. Here's how it works. The most basic defense of missile defense goes something like this. Nuclear weapons are very bad. And as it turns out, we can't really deter them super well. And as we just saw, we can't really stop their proliferation very well. This is bad. So if we could build a system to defend ourselves against incoming nuclear-tipped missiles, we could prevent mass catastrophe. That is a good thing. People often respond to this in some very bad ways. And these are three bad arguments you'll usually hear about nuclear defense that don't hold up. One is, well, we shouldn't do missile defense because it's destined to fail. It'll never work. And that's true. But the kindergartner level response is quite fair. Even if missile defense protects against one missile being stopped potentially saves a city. And saving a city from a nuclear bomb might save 1 million lives. The other argument that people tend to make is that missile defense is just hopeless against large arsenals. How will the United States ever prevent, for example, a Russian missile attack from destroying the United States? Best response to this is that that's not the point of missile defense. The point of the missile defense is not to prevent against a large-scale attack. It's to prevent against a rogue actor like North Korea from launching a missile attack with its 30-odd nuclear weapon arsenal. But at any rate, it doesn't much matter because the same logic from before applies here. The argument, though, that we're going to explore in greater depth is the argument that says missile defense is bad because countries react to missile defense by building larger arsenals. This argument shows some potential, and we'll explain how it can be improved in a moment. But the bigger problem with the argument is that it's often made by the same people who say missile defense is hopeless. If missile defense is hopeless, it's unclear why adversaries will engage in massive, expensive, costly arms racing without any real reason or need to do so. So what is ballistic missile defense, and why does it matter? It's worth starting this discussion by noting what ballistic missile defense is not. And it is not the Iron Dome, which is quite probably the most well-known and popularized example of missile defense, because the Iron Dome missile defense system in Israel is foundationally a cruise missile defense system. It intends to intercept missiles which are not ballistic, and that requires an understanding of ballistic as opposed to cruise missiles. Cruise missiles fly in the atmosphere. They're flying at normal altitudes, and they're usually powered exclusively by rockets. Where do ballistic missiles differ? These are rocket-propelled vehicles at first that are capable of flying at much higher altitudes, at much longer distances, and much faster speeds than cruise missiles. How? Because ballistic missiles go into outer space, is the kind of crude way to put it. And what they do is they take advantage of a ballistic trajectory. They fly into lower outer space, and then gravity essentially slingshots them towards their target on a downward sloping ballistic trajectory. There are 3 phases in the flight of a ballistic missile. This will become important when we explain how you intercept ballistic missiles. The first is the boost phase. This is when the rocket is first launched into outer space. It crosses the Kármán line out of the Earth's atmosphere. This lasts for about 5 minutes. Then the ballistic missile, or ICBM if you want to call it that, or SLBM if it's launched from the sea, enters mid-course phase. For about 20 minutes, the rocket adjusts its course, it accounts for initial errors, and subsequently, what it does is it takes off everything that is not the warhead. It puts the warhead into what's called a multiple independently targetable reentry vehicle, called an MIRV. The mid-course phase also deploys decoy warheads, which are intended, as we'll soon see, to fool missile defense systems by creating lots of warhead lookalikes that will stymie incoming missile interceptors. In the final phase of the ballistic missile trajectory, the independent reentry vehicle re-enters the atmosphere. It's usually flying well above Mach 10 times the speed of sound. At this point in time, decoys fall away. They're light, and so when they hit the Earth's atmosphere, they rapidly decelerate and often burn up. The real targets are much heavier. They're containing nuclear weapons. They fly to their target and detonate within about 60 seconds. This is visually what the flight path of a ballistic missile looks like. Boost phase for about 5 minutes, mid-course for about 20 minutes. In outer space, broadly speaking, that is where you cover the greatest amount of territory. The last 60-odd seconds is in the re-entry terminal phase. So what does ballistic missile defense do? It does 3 things. 1, ballistic missile defense systems detect that ballistic missiles have been fired. They then track that ballistic missile and identify its ballistic trajectory. They then launch interceptors, in other words, other missiles, to intercept the incoming ballistic missile. The first 2 steps are the ones that we'll spend the least time chatting about because they're by and large mostly solved. To detect a missile has been launched, you use a variety of radar systems as well as infrared satellites. What you look for is basically a sudden releasage of electromagnetic radiation and thermal energy. You map that with established records of different ballistic missiles by country. You determine that a rocket has been launched. Now you know a ballistic missile is in the air. Now the goal is to track it. The way that you do this is through infrared spectroscopy, which is just a fancy way of saying, as the rocket flies, it is giving off tons of heat, both as the rockets are propelling and burning through either liquid or solid-based fuel, but also because when the rocket enters outer space, it retains its heat profile it developed as it entered outer space, and infrared satellites monitor for that heat profile, tracking the missile on its course. What that brings you to is you have detected a missile has been launched, and you've tracked the location of the missile. But what you now need to do is you need to stop the missile from attacking. And in order to do that, you need to intercept the missile. And this is kind of weird to say, but this is actually how missile defense is done. What you literally do is you send a rocket to collide with their missile. And usually these are called kinetic kill vehicles, or KKVs. What a kinetic kill vehicle does is it does exactly what its name suggests. It kills the incoming ballistic missile through kinetic energy. It flies right into the incoming ballistic missile. That's what it does. Now, because kinetic kill vehicles are the dominant tactic used by ballistic missile defense systems, they can, at least in theory, intercept incoming ballistic missiles during boost, mid-course, or terminal phase. But in reality, there are lots of questions people ask about why KKVs are used at any stage, boost, mid-course, or terminal. For example, people often ask, why wouldn't you just put a nuclear weapon on the interceptor? Wouldn't that be really effective? Turns out not really. Most of the time you're intercepting either in or near outer space. Outer space does not have a lot of air molecules, so you actually don't get that much benefit from blowing up a nuclear weapon because overpressure and the effects of overpressure are quite limited. And on top of that, you mess with radar systems, which makes it difficult to detect other warheads. Reagan famously proposed the Star Wars system of why can't we use lasers as opposed to kinetic kill vehicles to take down incoming missiles, there's two reasons. One is just it's really difficult to get a high energy laser beam over thousands of kilometers because the intensity of lasers decreases with the square of distance. The second and more important reason is laser-based missile defense systems would easily be destroyed by the opposing country because the laser generator would give off huge amounts of heat when it fired that first laser. The generator would easily be identified by infrared satellites and easily destroyed by the opposing side. So you need to use kinetic kill vehicles. You need to smash kinetic kill vehicles into the opposing side's missiles. Where should you do it? You could do it during boost phase, but that's a bad idea. The reason it's a bad idea broadly is because you have very limited geographic ability to do this. Imagine Russia launches a nuclear weapon from the middle of Siberia. Even if, say, the United States was seriously trying to intercept the missile before it got out of outer space, the United States is launching its missile interceptors from outside Russian territory. Good chance you literally cannot reach the missile before it achieves mid-course phase in outer space. And you have a severe time constraint. You have only a couple of minutes to identify the missile has been launched, track it, determine its positioning. Oh, and by the way, the rocket is still firing, so it can maneuver its position and throw off the missile interceptor. Terminal phase is also a bad idea because time is a huge problem. Remember, terminal phase missiles are moving at like Mach 10. Now, at every phase, the missile is moving well over 10 times the speed of sound. But during the terminal phase, you only have a minute left. So your interceptors have no time at all to make errors. And that means that if your first interceptor misses, you do not have any ability to try again. More importantly, terminal missile defense is extremely limited in terms of range because you can't launch a missile interceptor 5,000 kilometers away when the missile is going to be hitting its target in 60 seconds. You need the missile interceptor to be launched relatively close by to the incoming missile, which means that you have to almost always do ground-based mid-course missile defense. This is what the United States does for its missile defense programs, and this probably is the future of ballistic missile defense by and large. Why would you potentially do ballistic missile defense, even though it seems impossible? There are two big upsides. The first upside is that you just have a lot more time. There are 20 minutes spent in mid-course. It is flying on a relatively modelable and computationally predictable trajectory, and that gives you an ability to understand where the missile will be and hence can intercept it with kinetic kill vehicles. Second, more important, when you target missiles during mid-course, you can weaponize what's called shoot, look, shoot firing doctrine. You fire a kinetic kill interceptor. If it misses, you look, you see it's missed, you fire again. And that allows you to shoot multiple interceptors at the same incoming weapon to maximize the odds of interception. There is, however, a huge problem with ground-based mid-course ballistic missile defense, and it's called target discrimination. Earlier, we mentioned the problem of decoys. The problem of decoys is when countries launch missiles, they don't just include actual warheads inside those missiles. They also include decoy reentry vehicles. Here, this shows you one actual warhead. It's the weird-looking one. And all those others, they're decoys. Here's the problem. What happens if you release 30 decoys and you only have 15 missile interceptors? How on earth are you supposed to stop the attack? You can't take out all of those reentry vehicles. So you have to distinguish the reentry vehicle from in other words, you have to distinguish the actual reentry vehicle from the decoys. This is really hard because it is very easy for an adversary to build their decoys to look nearly identical to the actual warhead. They can overwhelm ballistic missile defense systems by simply adding way too many decoys for interceptors to penetrate. They can disguise decoys to make them look the same temperature, to make them have the same shape, to have them appear to have the same mass, to have them appear to move at the same velocity. And that makes it very difficult to distinguish, or in other words, discriminate between decoys and non-decoys. And there are a whole range of measures that you can take to essentially make it impossible to even track these things. There's a common tactic called shrouding, where you basically conceal decoys, or you conceal, for that matter, real warheads in cold liquid nitrogen, which makes it functionally impossible to distinguish the heat of the missile, or the reentry vehicle to be precise, from the heat of the surrounding environment. Now, what you're probably thinking right now is, doesn't all of this just prove that the original criticism I put up on the slideshow was right, that ballistic missile defense is hopeless. Why should we spend billions of dollars on a hopeless missile defense program? Why? Here's why. I want you to imagine a very weird hypothetical. It would never happen, and so that's not why I'm asking you to consider it. But imagine it just for fun's sake, if you will. Imagine that one day, Biden and Xi Jinping have a nice sit-down discussion, and they decide to get really drunk together. And the two of them are very drunk, and Biden is so drunk that he decides to do something really stupid. He decides to leak a highly classified document to Xi Jinping that says, the United States has not solved target discrimination. Our missile defense program is hopeless. We think, in fact, we know for sure, we will only be able to intercept a grand total of just 10 missiles. That's it. We've spent decades and hundreds of billions of dollars, maybe even trillions, depending on how you do your accounting. And we just can't solve missile defense. It's hopeless. And Biden spills all the beans to Xi. He says it everything. And Biden anticipates that the reaction from Xi Jinping will be giddy. Xi Jinping will know for sure now that the United States can never defend against a possible missile attack by the Chinese. Hence, deterrence holds. China has first strike uncertainty against the United States. That's what Biden thinks. This has to be a great day for Xi Jinping. This has to confirm that nuclear relations between China and the United States are stable, right? It's actually not. If the United States told China, or in this case, Xi Jinping specifically, exactly how effective their system was, and confirmed quite clearly that the United States missile defense system can absorb even one missile with some level of success, that will terrify China or Russia or North Korea or any country opposed to the United States, and more generally, any country with nuclear weapons that has an enemy with a ballistic missile defense system. And here is why. We chatted earlier about the centrality of second strike capability to nuclear deterrence. And here was the logic we outlined. Nuclear deterrence only works if countries are able to survive a first strike counterforce attack and subsequently retaliate. We established that due to the inherent complexities of counterforce, you will never, ever, no matter how advanced your nuclear arsenal is, be able to guarantee destroy your enemy's nuclear arsenal. And that means nuclear counterforce is fundamentally unthinkable. And counterforce is unthinkable because there is always a chance that one or two or three weapons are left behind. No matter how good your intelligence is, no matter how accurate and destructive and lethal and penetrating your weapons are, you'll never have the guarantee that you will destroy the enemy's arsenal. And that is a lifesaver. Because if you're China prior to the age of ballistic missile defense, you knew for sure almost that at least two or three of your weapons would survive a US counterforce attack. Even if your arsenal was highly unsurvivable, there was always a chance one would survive. And that gave you comfort, because even if the United States believed it could execute counterforce, it never would try, because even one weapon surviving would mean San Francisco dies, New York blows up, Washington rains down with radioactive ash. No country would ever take that gamble. It would be insane. Ballistic missile defense changes things. Ballistic missile defense might not be perfect. It might not be highly effective. But the moment that Biden says something like, we know we can for sure intercept 10 missiles, he thinks that's a sign of weakness. China finds that terrifying. Ballistic missile defense makes counterforce possible because highly effective counterforce will almost certainly leave one or two weapons behind. Without ballistic missile defense, those weapons are nearly guaranteed to rain hellfire on the country that launched a counterforce strike. But with ballistic missile defense, BMD mops up the remaining weapons left behind after a counterforce strike. If the United States launched a counterforce attack against the PRC and wiped out 499 of China's 500 nuclear weapons, the one remaining nuclear weapon no longer poses an existential security threat to the United States because the relative ability for US ground-based ballistic missile defense to intercept and destroy that missile before it can hit the United States solves the puzzle of counterforce. This is why countries find ballistic missile defense infuriating and why they find it terrifying. They find it terrifying for the highly specific reason that ballistic missile defense is not defensive. Ballistic missile defense is functionally an offensive capability. This was precisely what happened in 2017 with the THAAD Terminal High Altitude Area Defense controversy involving South Korea. The South Koreans had considered moving towards an integrated missile defense system involving THAAD, which is the US's preeminent ballistic missile defense system. Admittedly, it focuses on terminal defense that works for South Korea because it's right next to its major nuclear adversary, North Korea, and hence it's able to protect the entirety of South Korea geographically with terminal defense. Why were China and Russia and North Korea so irked by THAAD? Maybe it's because THAAD is an effective way to protect South Korea against an offensive attack by Pyongyang or by Beijing or by Moscow. But that's not the real reason. The real reason is that for North Korea knew in that moment that the United States had massively improved the vitality and the viability of counterforce against North Korea. China and Russia shared a slightly different perspective. THAAD is a missile defense system. And as we established earlier, the first principle of missile defense is identification and tracking of ballistic missiles. THAAD integrates X-band radars, the radar systems that are highly capable of monitoring China's, and even for that matter, Russia's missile launchers to detect incoming ballistic missile attacks. The point is, THAAD, from the perspective of North Korea, China, and Russia, is an offensive element of the South Korean military. It is not ballistic missile defense. It functionally constitutes an offensive weapon against those three countries. That is why ballistic missile defense is controversial. So at the beginning of this section, I mentioned an argument that said ballistic missile defense is bad because it incentivizes countries to build up arsenals. And I dismissed that argument as silly because that argument is a bad argument. This argument is stronger. The logic goes like this. If you're China and the United States begins building an ever stronger ballistic missile defense network and apparatus intended to defend the United States against the remnants of a post-counterforce Chinese nuclear arsenal, the only way China gets around that problem is by building up its nuclear arsenal. The controversy over THAAD was years ago, and it was ultimately resolved, at least in part, by the South Koreans agreeing not to integrate X-band radars within THAAD within the US BMD system. However, almost certainly part of China's anxiety around its current nuclear buildup is driven at least in part by knowledge that the United States has some potentiality through a range of X-band radar systems deployed across the region to monitor China's nuclear arsenal, and that is concerning. The last section we'll chat about is nuclear technology and how it's changing and why that matters. At the basic core principle of this lesson is nuclear weapons are powerful at deterring conflict, but that deterrence rests on retaliatory second strike capability. Fortunately, that was never seriously in jeopardy because counterforce was never a serious possibility. That may be changing. There are three ways the world is evolving that should make you scared that nuclear war will, in fact, become possible. The first is increasing improvements in the accuracy of intercontinental ballistic missiles. The second is vast improvements in the depth, scale, frequency, and communicability of remote sensing technologies. And the third is an increasingly powerful global zero movement pushing for the complete abolition of nuclear weapons. Why are these three concerning when put together? Because they undermine the core principles of arsenal survivability. Here's how. In order to protect your arsenals from counterforce, you have three options. One,
Make your targets harder. For example, fortify your aircraft shelters, amass deeper missile silos. That makes it harder for the enemy to attack and to destroy your infrastructure. Second, conceal your nuclear infrastructure. Hide your weapons on road mobile tells. Put more nuclear weapons onto SLBMs, on SSBNs in the water. And third, build redundancy into your command and control structures and amass ever larger arsenals to deter countries from ever thinking about counterforce. Improvements in accuracy are gravely undermining the viability of the hardening strategy. Here's why. The more accurate that weapons are, they are more able to destroy hardened targets. The reason why, and mathematically there's excellent evidence behind this, the more accurate weapons are, the harder targets they are able to destroy. Because the more accurate a nuclear weapon is, the more probable it is to fall within a lethal radius of even the most hardened and most fortified targets. So no longer is a 50,000 psi missile silo safe, because highly accurate nuclear weapons can ensure that they pinpoint their destructiveness against those silos. Concealment is also struggling. Previously, if you put your weapons out onto TELs or SSBNs, you were probably good. That's not true anymore, unfortunately. The increasing improvements in satellite and radar technology allow countries to monitor roads, to monitor seas, to monitor passageways in ways that make it increasingly difficult to conceal and hide your nuclear weapons. And improvements in the shift towards arms control are very much well-intended. But there is a very real risk that as countries gradually reduce their nuclear arsenals, and to be clear, nuclear arsenals have fallen well over 85% since the end of the Cold War, that undermines the finality of counterforce. There's two other reasons why you should be concerned by these improvements. The first relates to the problem of fratricide. A common question people ask when it comes to attacking silos is, why wouldn't you just dump like 5 nuclear weapons on a missile silo? That would certainly destroy it, right? Simple reason is you can't. Here's why. When you drop the first nuclear weapon on a missile target, you can't drop another weapon for the first 2.5 to 3 seconds. Why? Because that immediate overpressure wave would throw the weapon off course. So you have to wait about 2.5 seconds for the overpressure wave to pass. If you put another weapon in there, good luck. You got it. You can do it. That second weapon will detonate. But after about 7.5 seconds, you can't put another weapon in. That's when the debris cloud starts to form. And that's where you end up getting a thick mass and dense of fireball and debris and smoke. And that makes it nearly impossible for an incoming nuclear weapon to actually detonate where it is intended to detonate. Now, here's why that matters. Fratricide historically meant you could at most put 2 weapons on a given target. Because if you tried putting in a third, it just couldn't fit in there. And that massively reduced the probability that nuclear counterforce could work. Because the probability that both weapons fail is pretty high, unfortunately, for a counterforce strategist. Improvements in accuracy, however, have allowed, crazily enough, for a third weapon to be put on targets. The basic reason why is that the improvements in weapons accuracy now means that when missiles miss, they almost always miss because they didn't fire in the first place and they don't detonate. And therefore, the remaining sources of missile failure are almost never caused by inaccurate weapons, which means you usually can fit 3 weapons onto a target. That improvement in accuracy greatly reduces the probability that hardened missile targets will survive a nuclear strike. Accuracy also matters because it means the probability that multiple nuclear weapons will remain drops dramatically. These are the major weapons in the United States military arsenal by year. CEP is a measure of accuracy. The smaller this number, the more accurate the weapon. This yield is in kilotons.
and REL stands for reliability, the percentage of weapons that will fire successfully. In 1985, if you were targeting an arsenal of 100 weapons, 42 would survive. In 2017, a vast improvement in accuracy, just 13 survive. By 2017, you're down to a CEP of 90 meters. That's highly accurate, just 8 survive. But still, that's unbearable. Turns out, missiles are becoming more accurate, and as they become more accurate, they're becoming more reliable. That greatly improves your odds of counterforce. You can do what's called missile reprogramming. That massively improves the odds of counterforce succeeding. You can add a third weapon into the mix, and you can use something called compensated fuse, which essentially allows you to utilize a volume-based approach to targeting that greatly increases the probability that your weapon will destroy the incoming, the targeted location. All of these things put together is devastating, because what it means, in short, is that you are able to undermine the core pillars of survivability. Hardening matters less than it ever did before. Concealment matters less than it ever did before. Redundancy matters less than it ever did before. Where does that leave us? Counterforce is the antithesis to deterrence, and counterforce is becoming increasingly viable. And that is arguably the greatest threat currently facing nuclear arsenals. Hopefully this was helpful. If you have any questions, feel free to reach out. Thanks so much for listening.